हेलो।
तेरी भी नहीं यार, तेरी भी नहीं यार।
आ तो रही है।
अब आ रही है हमारी आवाज?
अब आ रही है।
अब आ रही है ना? अरे,
हेलो। यहाँ तो आ रहा है। हेलो। हेलो।
हेलो। हाँ, आपकी नहीं आ रही है, हमारी तो आ रही है। हेलो, हमारी आवाज आ रही है, यूट्यूब पे जा रहे हैं, हमने जहाँ ज्वाइन कर रखा है उस पे भी जा रही है। हाँ, तो आपका स्पीकर और
हेलो। अब आवाज आ रहा है मेरा? अभी वहां पे आ रहा है ना? आप बोल के देखिए एक बार। आप बोलिए एक बार उधर से। हाँ,
अभी।
अभी आपका आवाज आ रहा है। ठीक है।
हाँ तो
सिस्टम तो ठीक काम कर रहा है, बस इनका वो केबल का
हाँ तो उनके केबल को बोलिए ना, चेक करें। हेलो, आवाज आ रही है? हॉल में आ रही है ना?
हेलो।
ठीक।
हेलो।
बोल। नहीं आ रही है।
हेलो।
ये यस 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 ऑडिबल।
इस हेलो।
वॉल्यूम थोड़ी सी माइक की अपनी इंक्रीज कर दीजिए।
हेलो।
ठीक।
हेलो।
Check, hello, hello, check, 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 check. check. Hello.
हेलो
Check, check, check.
हाँ
Hello.
आ रहा है।
हेलो चेक चेक हेलो ओके ओके The program will be start at 10:30.
అది అయిపోయిందా నిన్న అది అది చాలా థియరీ ఉంది దానికి ఎందుకంటే మనకు డిఫరెంట్ కండిషన్స్ బట్టి ఫ్రీ ఫ్లో అయితే ఏ విధంగా వస్తుంది సబ్మర్జిబుల్ ఫ్లో అయితే ఏ విధంగా వస్తుంది కండిషన్స్ సో అది ఎంత డీటెయిల్ గా చేయటం లేదేమో మనము చూద్దాం సరే చేశా సో ఏదో బిఏఎస్ అన్నారు కదా నాకు అసలు కూర్చొని మళ్ళా ఇలా పెట్టాను స్టార్ట్ చేస్తాను.
Check, check, test, test, test. Check, check, test, test. Check, one, check. Check, hi, hi. Check, hi.
There is a good news and bad news for you. If you are using Microsoft Office applications like Excel, PowerPoint, or Word, good news is now you can use AI to create all your Excel reports in less than 2 minutes, make stunning PowerPoint presentations in just 5 minutes, and automate your work to reduce your work by 2 hours daily. Bad news is, in 2023, if you only know basic Excel, PowerPoint, or Word, and you are doing all your work manually without using AI, forget a high-paying job. You won't even get a decent promotion in companies. If you want to learn how to integrate AI in Microsoft Office, I invite you to join my certified 3-hour ChatGPT and AI hacks in Microsoft Office workshop by clicking on the link below. Hi, I'm Jatan Shah, a Microsoft certified trainer and a Microsoft certified expert. In this workshop, you will learn the AI skills that will help you save at least 2 hours of your hard work every day. The free AI tools can boost your productivity by automating your work and increase your monthly salary by 3 times. You don't need to have any prior technical experience and you don't need to learn any kind of coding. You just need to tell the AI what you want to do and the AI will work for you. I have helped over 23,000 of employees who use Microsoft Office every day to work 10 times faster, become irreplaceable in their jobs, and unlock better job opportunities and better salary packages. Now it's your
Check, mic check. Okay. ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Very good morning to one and all present here. The city of dreams, Nama Bengaluru, has extended its warm welcome to all of you to be a part of this educational conference. On this auspicious day, remembering the strong pillars of our nation, that is farmer and a soldier, we are all set to start this event. I am Monica, your MC of today's event. Extend my warm welcome to all of you and request you all to please join your hands together as we begin this event. Thank you. It's an inaugurational function of sensitization program on Indian standards for irrigation engineers, organized by Bureau of Indian Standards, Water Resource Development, Government of Karnataka, and Department of Civil Engineering, UBCE, Bangalore University. This event will be backed up by industry experts, and without delay, let's welcome all the chief guests who are all on stage. Firstly, I would like to welcome our chief guest, IAS officer Shri Rakesh Singh, to our today's event. Sir, we welcome you. He is serving as an additional Chief Secretary, Water Resources Department, Government of Karnataka. Sir, we welcome you. Now, I would like to welcome Shri Krishnamurthy B. Kulkarni, Secretary of Water Resource Department, Government of Karnataka. We welcome you, sir. Now, I would like to welcome Shri R. Bhanu Prakash, Scientist, Director and Head of Water Resource Development, Bureau of Indian Standards. We welcome you, sir. And now I would like to welcome Professor of AMC Engineering College, Mr. Shashi Shankar. Sir, we welcome you to our event. And now I would like to welcome retired scientist from ISRO, Mr. Jagannath. Sir, we welcome you. We also have Shri Sanjay Pant, who will be joining us online and will be a part of our today's event through online. So we also welcome you. Now to begin the show with, we'll start with the invocation. So I request MTech Water Resource students, Rachna, Manasa and Kirtana to grace the occasion by singing a song of Lord Ganesha.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि गानचतुराय गानप्राणाय गानात्मरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुणवे गुरुगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसदानाध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डकण्डकाय गीतसाराय गीततत्त्वाय गीतगोत्राय धीमहि गूढगुल्फाय गन्धमत्ताय गोजयप्रदाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि
Thank you.
Thank you, girls. Thank you for gracing this occasion. I now would request Dr. Inayatullah M., Professor of DCE, UVCE, Director, Water Institute, to welcome you all and give a brief introduction about our chief guests. Welcome you, sir.
Good morning to all. Excellencies, distinguished delegates, ladies and gentlemen. It gives me great pleasure to extend to you all a very warm welcome on behalf of Bureau of Indian Standards, Water Resources Department, and Water Institute, UBC, Bangalore. It's my pleasure and privilege to welcome you all, the distinguished participants, to this event. I consider it a great honor to welcome our respected Honorable Shri Rakesh Singh Ji, IAS Officer, Additional Chief Secretary, Water Resource Department, Major and Medium Irrigations, Government of Karnataka. Your participation and contributions are greatly valued, and I'm glad to welcome you, sir. It's my privilege to welcome our Secretary, Water Resources Department, Sri Krishnamurthy B. Kulkarni, sir, KS Officer. I'm glad to welcome you, sir. So we are also having online virtually Sri Sanjay Panji, DDG Standardization to BIS, going to present keynote address. We welcome you, sir, for this program. I am pleased to welcome Sri R. Bhanuprakash Ji, Scientist, Director and Head, Water Resources Department, Bureau of Indian Standards. And I'm glad to welcome our professors, Jagannath sir, retired scientist, ISRO. And I'm also welcoming our professors, Shashi Shankar sir, Professor and Head, AMC Engineering College. Other dignitaries on and off the dais, and my dear friends, a warm welcome to you, all of you here today to the Sensitization Program on Water Resources, Standards for Irrigation Engineers, organized by Bureau of Indian Standards, Water Resources Department, and Water Institute, UVC, Bangalore City. Bureau of Indian Standards is a national standards body of this country for formulating the national standards through its 16 division councils covering various areas of standardization. Water Resource Department is one of such 16 departments in BIS, and it deals with its standardization and standard formulation in the area related to river valley projects, groundwater, coastal water, irrigation, etc., covering the entire hydrological cycle. The process of formulation of standard is performed through sectional committees, subcommittees, panels under Water Resources Division Council. One of the sectional committee, WRD 22, flood management, erosion management, diversion works, deals with the standardization of criteria for planning, design, construction, operation, maintenance, irrigation, and other related aspects of river training, works, barrage, weirs, and diversion works, etc. The Water Resources Department is one of the major departments in the government of Karnataka. The department harnesses surface water and irrigation and drinking water purposes. The vision of WRD is integrated water resource management to achieve scientific and efficient management of water, to increase crop per drop through a mix of improved efficiency of water application and net water gains through crop yield enhancement, adopt the practice that are environmentally sustainable and economically viable, close to the gap between the demand and supply of water, and to maintain the quality of water. Water Institute, UVC, Bangalore City, is a center of excellence because our UVC is already 108 years old, founded by Sir M. Vishwesvaraya Sir, Bharat Ratna Sir M. Vishwesvaraya Ji. So our alumni, which is there in India as well as in US and all, we initiated a Center of Excellence in Bangalore University, Civil Engineering Department as a water institute, which works with stakeholders and NGOs and R&D and all. The main purpose of Water Institute is to carry out advanced interdisciplinary research in the board of water, science and technology. And the purpose is to generate a trained manpower through short-term internships and projects to execute research and development projects with the specific deliverables in the area of water science and technology, to focus on problems in water management, including policy issues along the training component to train field engineers, to enhance the quality of life by ensuring water security by providing necessary research and development inputs, and to offer training, consulting, outreach in the water sector for sustainable development. We are also planning with the Bureau of Indian Standards and IMPRI and all to regularly give the trainings to the engineers and the researchers who are there in the water field and NGOs or who are interested in the water field to highlight them the Bureau of the Indian standard, the standards for all the hydraulic, hydrology and irrigation aspects, quality aspects, all those things. We want to have a regular training both online and offline. The purpose of this program is to bring together various stakeholders to discuss and enhance our understanding of crucial water resources standards, challenges associated with water resources in our country, and to promote sustainable water resource management practices. We believe that your expertise and insights would be invaluable in enriching the content and discussions during the program. Let us share together in a mission that will make water a right as well as a responsibility for all. We hope and trust that the delegates who are both offline, online, for all of them would have an enjoyable day, the program here. Thanking you. Thank you once again.
Thank you, sir. And now it's time to inaugurate this conference by lighting the lamp. I request all the chief guests who are on stage to please inaugurate this particular conference, Sensitization Program on Indian Standards for Irrigation Engineers by lighting the lamp. Okay. Ladies and gentlemen, I request you all to please stand up and join this occasion by joining your hands as well, please.
গতকাল 5টার সময় নাগাজ মানুষরা ফোন করেছিল, ফোন করে আমাকে আর সায়নদাকে যেতে বললো। গেলাম নিচে দিয়ে বলছে তোমাদেরকে গাড়ি দেওয়া হবে, জিনিসপত্র নিয়ে যাচ্ছ। কবে স্যার বলছি কালকে মানে ফ্রাইডেতে প্যাকিং হবে আর স্যাটারডে মর্নিং এখান থেকে আটজন করবো অ্যাভেলেবেল আছে, বাকি দিনে গাড়ি অ্যাভেলেবেল।
Thank you all. Thank you everyone. And we also have a special guest in our today's event who has joined us virtually. BDJ Standardization of our Bureau of Indian Standards, Mr. Sanjay Pansar. I request you to please address the gathering with your keynote, sir.
Thank you very much. On behalf of Bureau of Indian Standards, Water Resources Department, Government of Karnataka, and Water Institute, I welcome all of you to this very important event. And especially, I would like to thank the chief guest of the day, Shri Rakesh Singh Ji, IAS, Additional Chief Secretary, Water Resources Department, Major and Medium Irrigation, Government of Karnataka, and guest of honor of the event, Shri Krishnamurthy B. Kulkarni, KES, Secretary, Water Resources Department, Major and Medium Irrigation, Government of Karnataka, and all other dignitaries on the dais of the dais, my own colleague, Mr. Bhanu Prakash. The Bureau of Indian Standards, as you know, is the national standards body of the country and is engaged in development of national standards called Indian standards. And so far, more than 22,000 Indian standards have been formulated by BIS in diverse areas of technology and economy. As already mentioned, there are 16 divisions under which these standards have been formulated, more than 22,000, which include civil engineering, water resources, electrotechnical, electronics and IT, mechanical engineering, metallurgical engineering, textiles, petroleum, coal and related products department, chemical department, and even medical and hospital planning department, and now even Ayush department, the 16th department. So under these areas, we are formulating a series of standards on a regular basis. The entire work is done through technical committees, which are called section committees. And in particularly, there are more than 1,800 Indian standards formulated in the field of civil engineering, most of which are quite relevant to the water resources sector also, because a lot of building construction or even building material standards are covered there. Loading codes, structural design codes, codes of practices for good practices for construction, and even National Building Code of India is also there to help in building construction aspects. And through water resources division, we have around 460 Indian standards formulated. They have been formulated which are of direct relevance to irrigation engineers. They include the technical committees or areas such as hydrometry, groundwater, geological exploration, dams and appurtenant structures, canals, even coastal zone water management, water resource management, environmental impact assessment and management, reservoirs and lakes, gates and walls, canals and cross drainage works, etc. So these are some of the 17 technical committees called section committees under which these 460 standards have been formulated. You would be glad to know that BIS has created 4 more technical committees recently on small hydropower plants, urban flooding, repair, retrofitting and rehabilitation of dams, glacier lake outburst floods and landslide lake outburst floods. And we propose to initiate work in these 4 areas also. Broadly, there are these standards. So, and additionally, there are standards on water quality, irrigation equipment, and water management, which are dealt by our different divisions. There are and then testing of water, quality water, and all those things. Well, these areas, when we are making standards, we have planned for next 5 years what standards we need to be formulated. We have a Standards National Action Plan, SNAP. This Standards National Action Plan is available in BI's website. So if somebody is interested, he can always go to BI's website and see this. I would request Mr. Bhanu Prakash also to throw more light on this. Here we have proposed more areas of standardization on groundwater, coastal zone water management. We have identified subject on disaster mitigation and management, hydrostructure construction, operation and maintenance, then water resource management, environmental impact assessment. Some 70 areas, more than 50 areas have further identified for next 5 years where we need to work. My request today is that we have joining, because the time is very precious. All of you have gathered and sparing your valuable time. We should debate today and discuss and come out with the important resolutions, and these resolutions would be directly utilized by the 17 plus 4, 21 technical committees of our water resources department. the objective is that the irrigation engineers who are already qualified and competent to do the job, how to do their capacity building, and so that we have the highest standards of quality in the field of water resources and irrigation. And BIS is going to hold more such events in different parts of the country. And I request that we create a large pool of stakeholders who are already always informed of all these developments which are happening, new standards being formulated, standards being revised, standards being amended, and events being organized for capacity building. With that, I thank once again all of you for having joined, including the conveners of the event, Dr. Inayatullah M, Professor, Department of Civil Engineering, UBCE, and Director, Water Institute at the Center of Excellence, as he mentioned, as well as Dr. V. Jagannatha, former scientist, ISRO. And with that, I thank you and wish the event all the success. Thank you so much.
Thank you, sir. I now would like to welcome Shri B.V. Subbarao, sir, to our today's event. Sir, we welcome you. Thank you, sir. And it's time for our chief guest to, address, to let them to address you all. But before that, I'll have a very short time in describing their introduction in my own words. So here we have. He did his schooling at Lucknow, graduation at St. John's College, Agra University, 1982. Did his MA Psychology from Agra University in 1984 and LLB from Allahabad University in 1987. Worked as a lecturer in psychology under Gorakhpur University during 1987 and 89 before joining civil service. So his journey in civil service started in 1989, served as Assistant Commissioner and Sub-Divisional Magistrate, Bijapur, 1991 and 1993. As Chief Executive Officer, Jilla Panchayat, Tumkur District during 93 to 97. Deputy Commissioner and District Magistrate to Hassan District during 97 and 2000. Deputy Commissioner and District Magistrate in Bijapur District during 2000 to 2002. Deputy Commissioner and District Magistrate, Uttar Karnataka District, Karwar during 2002 to 2004. Secretary to Honorable Chief Minister of Karnataka during 2005 and 7, and additional charge of Secretary, ITBT and MD Kionics. CMD, Hoti Gold Mines during 2007 and 8. PS to MOS Railways, Government of Karnataka in 2009 and 10. PS to Minister of Law and Justice, Government of India in 2010 and 11. Not just that, but we also have his contribution to our Government of Karnataka more. So he also served as a Joint Secretary, Minister of Home Affairs, Government of India in 2012 and 15. MD of Karnataka Milk Federation, Government of Karnataka in 2015 to 19. Additional charge as a special officer to Mahamastakabhisheka, Belagola, Special Events of Karnataka since 2017. Principal Secretary for Government of Karnataka, Water Resource Department from 2016 to 19. Additional charge as a Commissioner, Bangalore Development Authority from 2017 to 19. Additional charge as Chairman, Belgavi Smart City Limited, Karnataka from 2018 to 19. Additional charge as Electoral Roll Observer, Ramnagara District, 2018 to 20. Additional charge as a Chief Secretary, Government of Karnataka, Medical Health Education Department in 2018. Additional charge as an Additional Chief Secretary for Women and Child Development Department in 2019. Additional Chief Secretary for Government of Karnataka, Water Resources Department since 2016 to 21. Presently holding additional charge as Additional Chief Secretary, Government of Karnataka, Water Resource Department since 2021. Presently regular working Additional Chief Secretary, Government of Karnataka, Urban Development Department since 2021. Also holding additional charge as a Chairman, Tumkuru Smart City Limited. Also additional charge as a Chairman, Bengaluru Smart City Limited, Karnataka. So it goes on. So I now take the esteemed pride in welcoming our IAS officer, Shri Rajesh Singh, to address you all.
Good morning to all. It was becoming more boring because nobody here has come to know about me. It is about the seminar. Honorable delegates, dignitaries on the dais. I don't know who's the delegate, who's the dignitary, because after meeting Jagannath Sahab, no, in Hindi Kalnali, people used to say that learning is what? Permanent. Learning is never ending, but whether to be practiced or not, I don't know. Learning is never ending. So it's a great occasion. Honorable Professor Sanjay Pant, because he's not around, all of us are here. I fumble. Very regularly I fumble. And today also I fumbled because when I saw the list of the program, what I saw that one has to speak after the address by the guests of honor. So all these dignitaries were supposed to talk first. So I was supposed to pick up one or two things from their speech and then speak. But it happened the other way. As they said earlier, learning must be a very permanent thing. And just to give you a small reference, I don't know about standards much. There are experts, professors who will use this day and the 2 days to make us more sensitive and understand things better. Just in the context of water, my personal experience, till I came to Karnataka, I never understood the relevance of water because I came from a place where in my school and all, the toilet tap will be always on because I think that time water was in abundance. Now they must also be facing the problem of scarcity. So what I'm trying to convey that we never realize the relevance of many of the things and water being the most important. Just to give you a connected story, which all of you must be knowing. Today, these days, for last 4-5 days, Israel is in a great news. I don't know how many of you know this story. Not story, it's a fact. After Second World War, I think it must be around 1947-48, the present Israel, Jordan, those areas were totally desert. I don't know how many of you have visited, but now if you visit, it is almost green except few portions of Jordan. So 1947-48, when my facts may be wrong, but the story goes like this. When this new country called Israel was in the making, the Jews started collecting. And you know the story? What they decided that as the country was in a great economic crisis, so they decided that the group of people will go to different directions and they will settle themselves. And that is what happened in 47-48, if my years are correct. And they started going, and they must be a group of 50 people, 60 people, 75 people, 100 people, 10, 20, 30 families. And they went and started living a cooperative living. That cooperative living is even relevant today, but last 15 years it has slightly got diluted. The concept, I'm coming to water later. The concept was called kibbutz. So kibbutz is a concept where it is corporate living. For example, the shirt I'm wearing today, the next day after getting cleaned, it is worn by somebody else. The car which I'm using today is being used by the community per se. Then say today or 1 week or 10 days, I'm working in the plumbing section. After that, I go to the agriculture section. Then I go to the dairy section, things like that. Dairy becomes very important. The basic point behind this that in 47-48, everyone was given one glass of water, just one glass of water per day for all his or her requirements. And today, for last, I think 20 years, the entire globe is learning from Israel only how to use or better efficiency of water. From where it has come? It has come from these kind of experts, conferences, workshop, that from a place where they were having no water kind of a situation, they have come as a world leaders. So my request to you, please make use of the best, please make best use of these conferences. The experts who are around, they have great experience, both practical and academic, to teach us further. People like me, or the generation in which I belong and to the category of work I do, there is nothing great to learn, because most of us are failed people who have connived with the wrong set of people in the society. And this wrong set of people can come from every walk of life. There are wrong bureaucrats, there are wrong people in every sectors, but academics is still one of the sectors where most of the people are very sensitive, committed, and they show you the path. So here is an occasion, learn the best, practice, and make a better India, better Karnataka, and better world. Thank you. Thanks for calling me.
Thank you, sir. So without delay, I now would like to welcome our case officer, Shri Krishnamurthy B. Kulkarni, sir, Secretary to Government of Karnataka, Water Resource Department. Ladies and gentlemen, please join your hands together in welcoming sir near the dais.
Beda. That's enough. Thank you. Good morning to everybody. Respected our Honorable Sir, Sri Rakeshing Sir, Professor Shashi Shankar, Professor Subrab, and Sri Sanjay Pant, DDG from Bureau of Indian Standard, Sri Banu Prakash, scientist from Water Resource Development Department, BIS, Dr. Inayatullah, Director, Water Institute, Bangalore University, Dr. Jagannath Sir, former scientist from ISRO, and my colleagues here. I would like to speak in Kannada just for my convenience. ಇಲ್ಲಿ ಟಾರ್ಗೆಟ್ ಗ್ರೂಪ್ ಇರೋದು ಇರಿಗೇಷನ್ ಇಂಜಿನಿಯರ್ಸ್. ಈ ವರ್ಕ್ಶಾಪ್ನ ಮಾಡಲಿಕ್ಕೆ ಭಾನುಪ್ರಕಾಶ್ ಅವರು ಮತ್ತು ಇನಾಯತುಲ್ಲಾ ಅವರು ಬಂದಾಗ ನಮ್ಮ ಎಸ್ ಸರ್, ರಾಕೇಶ್ ಸಿಂಗ್ ಸರ್ ವಾಸ್ ವೆರಿ ಕೈಂಡ್ ಇನಫ್ ಟು ಅಗ್ರಿ ಫಾರ್ ದಿಸ್ ಫಂಕ್ಷನ್. ಸೊ ಅವರು ಇಮಿಡಿಯೇಟ್ ಆಗಿ 1 ವೀಕಲ್ಲೇ ಈ ಪ್ರೋಗ್ರಾಮ್ನ ಆರ್ಗನೈಸ್ ಮಾಡಿದ್ದಾರೆ. ಇಲ್ಲಿ ಟಾರ್ಗೆಟ್ ಗ್ರೂಪು ನಮ್ಮ ಇಲಾಖೆಯ ಜಲಸಂಪನ್ಮೂಲ ಇಲಾಖೆಯ ಇಂಜಿನಿಯರ್ಸ್ಗಳು. ನಮ್ಮ ಇಲಾಖೆಯ ಒಂದು ಅನಿಸಿಕೆ ಏನಿದೆ ಅಂದರೆ, ಇದು ನನ್ನ ಪರ್ಸನಲ್ ಅನಿಸಿಕೆ ಕೂಡ, ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸು, ಕೋಡ್ಸ್ ಆಫ್ ಪ್ರಾಕ್ಟೀಸಸ್ಸು ಮತ್ತು ಸ್ಪೆಸಿಫಿಕೇಶನ್ಸು ಓನ್ಲಿ ಡಿಸೈನ್ ಇಂಜಿನಿಯರ್ಸ್ಗೆ ಮತ್ತು ಕ್ವಾಲಿಟಿ ಕಂಟ್ರೋಲ್ ಇಂಜಿನಿಯರ್ಸ್ಗೆ ಮಾತ್ರ ಇದು ಸಂಬಂಧಿಸಿದ್ದು. ನಾವು ಎಕ್ಸಿಕ್ಯೂಟಿವ್ ಲೈನಲ್ಲಿ ಇದ್ದೀವಲ್ಲ, ನಮಗೇನಿಲ್ಲ ಕೆಲಸ, ಬರೀ LBD ಅಷ್ಟೇ ನಮ್ಮ ಕರ್ತವ್ಯ. ಲೆಂತ್, ಬ್ರೆಡ್, ಡೆಪ್ತ್ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡ್ಕೊಂಡು MB ಬುಕ್ ಬರ್ಕೊಂಡು ಹೋಗೋದಷ್ಟೇ ನಮ್ಮ ಕೆಲಸ ಅಂತ ಒಂದು ಭಾವನೆ ನಮ್ಮಲ್ಲಿದೆ. ಈ ಭಾವನೆಯನ್ನು ಅಳಿಸ್ಲಿಕ್ಕೆ ಖಂಡಿತ ಈ ಸೆಮಿನಾರು, ಈ ವರ್ಕ್ಶಾಪು ಅದನ್ನ ಅಳಿಸ್ಲಿಕ್ಕೆ ಸಹಾಯ ಮಾಡುತ್ತೆ ಅಂತ ನನ್ನ ಭಾವನೆ. ಈಗ ಕಾಮಗಾರಿಯ ಗುಣಮಟ್ಟ ಕಾಪಾಡ್ಕೊಂಡು ಹೋಗ್ಲಿಕ್ಕೆ ಡಿಸೈನ್ ಇಂಜಿನಿಯರ್ಸ್, ಕ್ವಾಲಿಟಿ ಕಂಟ್ರೋಲ್ ಇಂಜಿನಿಯರ್ಸ್ ಎಷ್ಟು ಇಂಪಾರ್ಟೆಂಟೋ ಅಷ್ಟೇ ಇಂಪಾರ್ಟೆಂಟು ನಮ್ಮ ಫೀಲ್ಡ್ ಇಂಜಿನಿಯರ್ಸ್. 70% ಆಫ್ ದಿ ರೆಸ್ಪಾನ್ಸಿಬಿಲಿಟಿ ಇರೋದು ನಮ್ಮ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಇಂಜಿನಿಯರ್ಸ್ ಮೇಲೆ. ಅವ್ರಿಗೆ ಸ್ಪೆಸಿಫಿಕೇಶನು, ಕೋಡ್ ಆಫ್ ಪ್ರಾಕ್ಟೀಸ್ ಬಗ್ಗೆ ಐಡಿಯಾ ಇದ್ದರೆ ಕಾಮಗಾರಿಯಲ್ಲಿ ಗುಣಮಟ್ಟ ಕಾಪಾಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಯಾವುದೇ ತೊಂದರೆ ಇರೋದಿಲ್ಲ. ಏನಾಗಿದೆ, ನಮ್ಮಲ್ಲಿ ನಾವು ಡಿಗ್ರೀಸಲ್ಲಿ ಓದಿದಾಗ ಮರ್ತಿರೋಂಥ ಇದನ್ನೆಲ್ಲ ಮರ್ತ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಹಾಗೆ ಕೆಲಸ ಮಾಡ್ತಾ ಇರ್ತೀವಿ. ನಾನು ಉದಾಹರಣೆ ಹೇಳಬೇಕಂದ್ರೆ, ಐ ಸ್ಟಾರ್ಟೆಡ್ ಮೈ ಕರಿಯರ್ ಥ್ರೂ ಕ್ವಾಲಿಟಿ ಕಂಟ್ರೋಲ್ ಸಬ್ ಡಿವಿಷನಿಂದ. ಸೊ ಹೀಗಾಗಿ ನನಗೆ ಆ ಟೈಮಲ್ಲಿ ಸುಮಾರು ಸ್ಟ್ಯಾಂಡರ್ಡ್ IS ಸ್ಪೆಸಿಫಿಕೇಶನ್ ಓದ್ಕೊಳ್ಳಿಕ್ಕೆ ನನ್ನ ಟೈಮ್ ಇತ್ತು, ಓದ್ಕೊಂಡಿದ್ದೀನಿ. ಆದರೆ ನಾನು ಸೈಟಲ್ಲಿ ಹೋದಾಗ ನಮ್ಮ ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡ್ತಿರೋಂಥ ಸೀನಿಯರ್ ಇಂಜಿನಿಯರ್ಸ್ಗಳಿಗೆ ಹೊಸ ಸ್ಪೆಸಿಫಿಕೇಶನ್ ಬಗ್ಗೆ ಐಡಿಯಾ ಇರಲಿಲ್ಲ. ನಾನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಹೇಳಲಿಕ್ಕೆ ಇಷ್ಟಪಡ್ತೀನಿ. IS 456 ನಮ್ಮದು ಕೋಡ್ ಆಫ್ ಪ್ರಾಕ್ಟೀಸ್ ಫಾರ್ ಪ್ಲೇನ್ ಆ್ಯಂಡ್ ರಿನ್ಫೋರ್ಸ್ ಕಾಂಕ್ರೀಟ್ ಇದೆ. ಅದು 1970 ಇದಾಗಿತ್ತು. ನಾನು ಹೇಳ್ತಿರೋದು 95 ಪೀರಿಯಡ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, 95, 99 ತನಕ ಬಂದಾಗ. ನೆಕ್ಸ್ಟ್ 2000 ರಿವಿಷನ್ ಆಯಿತು. ರಿವಿಷನ್ ಆದಾಗ 2001 ಎಷ್ಟೋ ಜನರಿಗೆ ಈ IS 456 ರಿವಿಷನ್ ಆಗಿದೆ, 2001 ಎಡಿಷನ್ ಬಂದಿದೆ ಅಂತ ಯಾರಿಗೂ ಗೊತ್ತೇ ಇರಲಿಲ್ಲ. ಅವತ್ತು ಲಕ್ಕಿಲಿ ನಮ್ಮ ಪ್ರೊಫೆಸರ್ ವಿಶ್ವನಾಥ್ ಅವರು, ಟಾಸ್ಟಿಲ್ ಫೌಂಡೇಶನ್ ಅವರು ಒಂದು ಯಾವುದೋ ಅದಕ್ಕೆ ಬಂದಿದ್ರು. ಅವ್ರಿಗೆ ನಾವು ರಿಕ್ವೆಸ್ಟ್ ಮಾಡಿದ್ವಿ, ಸರ್ IS 456 2000 ಬಗ್ಗೆ ಸ್ವಲ್ಪ ನಮಗೆ ಎನ್ಲೈಟನ್ ಮಾಡಿ ಅಂದಾಗ, ಸಾಯಂಕಾಲ ನಮ್ಮ IB ಇದರಲ್ಲಿ ಪ್ರೀಮಿಯಸ್ಸಲ್ಲಿ ಅವರು ಹೈಲೈಟ್ ಮಾಡಿದ್ರು ವಾಟ್ ಇಸ್ ದ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ IS 456 1978 ಆ್ಯಂಡ್ 2001 ಅಲ್ಲಿ ಏನಾಗಿದೆ. ಸೊ ಜಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬೇಕಾದ್ರೆ ಕವರ್ ಡೆಪ್ತ್ ಹೇಗೆ ಕೊಡಬೇಕು, ಮೊದಲು ಎಷ್ಟಿತ್ತು ಈಗ ಎಷ್ಟಿತ್ತು, ಈ ಥರ ಅವರು ನಮಗೆ ಎನ್ಲೈಟನ್ ಮಾಡಿದರು. ಅವಾಗ ಎಲ್ಲರೂ ಇಂಜಿನಿಯರ್ಸ್ಗೆ ರಿಯಲಿ ನಮಗೆ ಅವತ್ತು ರಿಯಲೈಸ್ ಆಯಿತು, ನಾವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ಗಳ ಬಗ್ಗೆ ನಾವು ಅಪ್ಡೇಟ್ ಮಾಡ್ಕೊಳ್ಬೇಕು ಅನ್ನೋದು ಅವತ್ತು ನಮಗೆಲ್ಲರಿಗೂ ಒಂದು ಅನುಭವ ಬಂತು. ಈ ಥರ ಈ ಸೆಮಿನಾರ್ ನಮಗೆ ಪ್ರಾಕ್ಟೀಸಸ್ ಬಗ್ಗೆ ಒಂದು ಎನ್ಲೈಟನ್ಮೆಂಟ್ ಮಾಡಿಕೊಡ್ತಂತ ಅಂತ ನನ್ನ ಭಾವನೆ. ಆದ್ದರಿಂದ ನಮ್ಮ ಎಲ್ಲ ಇಂಜಿನಿಯರ್ಸ್ಗಳು ಇನ್ವಾಲ್ವ್ ಆಗಿ ಇಡೀ ದಿವಸ ಇವತ್ತಿನ ದಿವಸ ಈ ಪ್ರೋಗ್ರಾಮಲ್ಲಿ ಭಾಗವಹಿಸಿ ಕಲ್ಕೊಳ್ಬೇಕಂತ ನಾನು ಒಂದು ನಿವೇದನೆ ಮಾಡ್ಕೊಳ್ತೀನಿ. ಆಮೇಲೆ ನೆಕ್ಸ್ಟು ನಮಗೆಲ್ಲ ಗೊತ್ತಿದ್ದಂಗೆ ಅಕ್ಟೋಬರ್ 14 ಇವತ್ತಿನ ಸೆಮಿನಾರ್ಗೂ ಅಕ್ಟೋಬರ್ 14ಕ್ಕೂ ಭಾಳ ಕೋರಿಲೇಟ್ ಇದೆ. ಏನಂದರೆ ಅಕ್ಟೋಬರ್ 14 ಈಸ್ ಸೆಲೆಬ್ರೇಟ್ ಆಸ್ ಎ ವರ್ಲ್ಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಡೇ ಅಂತ ಸೆಲೆಬ್ರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ದಿ ಥೀಮ್ ಆಫ್ ದಿಸ್ ವರ್ಲ್ಡ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಡೇ ಈಸ್ ಶೇರ್ಡ್ ವಿಷನ್ ಫಾರ್ ಬೆಟರ್ ವರ್ಲ್ಡ್ ಅಂತ ಇದೆ. ಸೊ ಈಗ ನಮ್ಮ ಬ್ಯೂರೋ ಆಫ್ ಇಂಡಿಯನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಭಾನುಪ್ರಕಾಶ್ ಅವರು ನಮಗೆಲ್ಲ ಶೇರ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ಅವ್ರ ವಿಷನ್ನ ಬ್ಯೂರೋ ಆಫ್ ಇಂಡಿಯನ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ದು. ಸೊ ಫಾರ್ ದಿ ಬೆಟರ್ ವರ್ಲ್ಡ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ. ಈ ಇದರಲ್ಲಿ ನಾವೆಲ್ಲ ಭಾಗಿಯಾಗಿ ಈ ಸ್ಟ್ಯಾಂಡರ್ಡ್ಸ್ ಬಗ್ಗೆ ಎಲ್ಲ ಅಪ್ಡೇಟ್ ಮಾಡಿಕೊಂಡು ಮುಂದಿನ ನಮ್ಮ ಸರ್ಕಾರದ ಕಾಮಗಾರಿಗಳ ಅನುಷ್ಠಾನದಲ್ಲಿ ಒಂದು ಒಳ್ಳೆ ಗುಣಮಟ್ಟದ ಕಾಮಗಾರಿ ಮಾಡಲಿಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡೋಣ ಅಂತ ಹೇಳಿ ಆಶಿಸ್ತಾ ನಾನೊಂದು 2 ಮಾತು ಮುಗಿಸ್ತೀನಿ. ನಮಸ್ಕಾರ.
Thank you, sir. Now I would like to talk about this gentleman, Shri R. Bhanuprakash sir, Director and Head of Water Resource Department, Bureau of Indian Standards, New Delhi, India. He's a civil engineer and has done his bachelor's in civil engineering from PS College of Engineering, Mandya, Mysore University. He did his MTech in industrial structures from Mysore University. Shri R. Bhanuprakash has more than 34 years of experience in various fields of civil engineering. So, sir, without a delay, now I would like to welcome Shri R. Bhanuprakash sir to please present the presidential remarks.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Respected Rakesh Singh sir, or Krishnamurthy sir, Secretary sir, or Shashi Shankar sir, Vinayatula sir, and Jagannatha sir, our distinguished guest today, and our colleagues who are joined online, and our honorable irrigation engineers joined today for this session. It is my great pleasure to welcome all of you for this sensitization program on Indian standards of water resources, especially tailored for our esteemed irrigation engineers. So today we are here for the purpose of making full awareness of these standards available under Water Resources Department of Bureau of Indian Standards, national standard body, to in all the formats of our water sources. Our esteemed engineers play a crucial role in this endeavor. Our expertise, dedication, and innovative solutions are instrumental in shaping the future of water resources management in our nation. Through this program, we aim to equip you with the latest insights, methodologies, best practices outlined the Indian standards, ensuring that your work aligns seamlessly with the highest industry benchmarks. To all the participants, I encourage you to actively engage, ask questions, collaborate with your peers. This program is just not a learning opportunity, but also a platform for meaningful discussions and the exchange of ideas that will undoubtedly contribute to the betterment of our water resources management practices, good practices. So today we have technical sessions followed by this. We are having good speakers from all over the country, and also academic institutions. They are eager to share their knowledge about the standards of Water Resources Department. So I request all of you to kindly involve and get an insight into that. So with this, I complete my few words. Thank you.
Thank you, sir. Ladies and gentlemen, we have a small high tea session now, and after that, other sessions will be continued. But before that, we would like to honor all our chief guests. And from this, I would like to welcome Dr. Inayatullah, Professor of UVCE, Director, Water Institution.
Now it is my honor and privilege now to give a vote of thanks in all those who helped make the program happen, and to acknowledge the contribution of those who worked hard for successfully completing this program. Sensitization program on water resource standards for irrigation engineers. I, on behalf of BIS, WRD and Water Institute, supporting team, and on my behalf, I extend a very hearty thanks to all our speakers and our guest, everything. I must mention a deep sense of appreciation and a big thanks to our chief guest, Shri Rakesh Singh Ji, IAS officer, Additional Chief Secretary, Water Resources Department, who always keep in mind the present and future. So I thank you, sir, and please I request to accept a memento from this.
Check. We have a small word of, small, Nudi Namana from Dr. Shashi Shankar, sir.
ಇದು ರಾಕೇಶ್ ಸಿಂಗ್ ರವರ ಕುರಿತಾಗಿ ಇಂಗಾಲದ ಹೆಜ್ಜೆ ಗುರುತು ಇದರ ಪ್ರಭಾವವನ್ನು ಅಳಿಸುತ್ತಾ ವಿಶ್ವದಿ ತ್ವರಿತು ಮಾನಕ ಸಂಸ್ಥೆಯ ಚಿಂತನೆಯ ಕುರಿತು ವಿಶ್ವಶಾಂತಿ ಮಂತ್ರವ ಪಠಿಸುತ್ತಾ ಸರ್ವನಾಶ ಪರಂತು ರಾಕೇಶ ಸಿಂಹ ಭಾನುಪ್ರಕಾಶ ರಾದಿಯಾಗಿ ನಮಗೆಲ್ಲ ಶಕ್ತಿ ಬಂತು.
Now I keep on record on invitation to our guest of honor, Sri Krishnamurti B. Kulkarni. Sir, please kindly accept here.
Krishnamurti Kulkarni, sir.
I request Shri R. Bharat Prakash, sir, to please receive our honoring. And I request Rakesh, sir, to please present the memento to him. ಹಾಗೆ ಈಗ ಶಶಿಶಂಕರ್ ಸರ್ ಇದ್ದಾರೆ, ಅವ್ರಿಗೂ ನಮ್ಮ ಕಡೆಯಿಂದ ಒಂದು ಗೌರವವನ್ನ ಸಮರ್ಪಿಸ್ತಾ ಇದ್ದೀವಿ. ದಯಮಾಡಿ ಎಲ್ಲ ಡಿಗ್ನಿಟರೀಸ್, ಐ ರಿಕ್ವೆಸ್ಟ್ ಯು ಟು ಪ್ಲೀಸ್ ಹಾನರ್ ಡಾಕ್ಟರ್ ಶಶಿಶಂಕರ್ ಸರ್, ಪ್ಲೀಸ್. Thank you, sir. We also thank everyone for their participation and their willingness to participate beyond their comfort zone. I especially thank the people who have been the backbone of this event, our technical arrangement team and media people. Thank you, everyone. After a high tea session, the program will be continued as per the, the plan which has been given to all of you. Thank you. Ladies and gentlemen, we have a high tea which is being arranged outside. I request you all to please take 15 minutes of your time and have a high tea, and please come back within 15 minutes. ಹೊರಗಡೆ ಟೀ ಹಾಗೂ ಸ್ನಾಕ್ಸ್ ಅನ್ನ ಅರೇಂಜ್ ಮಾಡಲಾಗಿದೆ. ದಯಮಾಡಿ ಒಂದು 15 ನಿಮಿಷದಲ್ಲಿ ಟೀ ಅನ್ನ ಸೇವಿಸಿ ವಾಪಸ್ ಬರಬೇಕು ಅಂತ ಕೇಳ್ಕೊಳ್ತೀವಿ ಎಲ್ರು.
Oh, sir, it's really ಪದ್ಯ ಅದು.
ಅದು ನಿಮ್ಗೆ ಏನು ಆಸೆ ಇತ್ತು ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ Sir, he is the
ಬೇಡ ಸರ್, ಇದ್ರಲ್ಲಿ ಮಾತಾಡಿದ್ರೆ ಕ್ಯಾಮ್ರಾ ಔಟ್ ಹೋಗಲ್ಲ.
ನಾವು ಆಕ್ಚುಲಿ ಒಂದು ನೀರು ಕೊಟ್ಟು ಮೀಟಿಂಗ್ ಮಾಡಿದ್ದೀವಿ.
Right. Sir, sir. MD. Sir, we are quiet, but very highly start from that. What's that? No. Here.
ಕೊಡೋಣ ಸರ್ ಇವ್ರಿಗೆ ಕೊಡೋಣ ಸರ್ ಯಾರಿಗೆ
ವಿಕ್ರಮನ್ ಟೀಮ್ ಅಲ್ಲಿ ಮಾಡ್ತಾರಂತ
ಕೊಟ್ಬಿಟ್ಟೆನ
ಅವರು ಕೊಡೋಣ ಅವ್ರು ಮಾಡ್ತಾರೆ. ಕರೀರಿ ಅವ್ರ ಶಿಷ್ಯರ್ ಕರೀರಿ.
ಎಲ್ಲಿ ಹೋಗಿದ್ದಾರೆ ಎಲ್ಲರೂ ಅದೇ ನೋಡುತ್ತೆ.
ಅಯ್ಯೋ
ಒಂದ್ ನಿಮಿಷ ನನಗೂ ಇಲ್ಲಿ ಯಾರು ಮಾತಾಡಿಲ್ಲ.
Yes, sequence. Speakers. अभी सबसे पहले यह है, सेकंड नंबर पे यह है, थर्ड नंबर पे यह है, फिर लंच हो जाएगा. पहले वाले बस इतना इंट्रो देना. Welcome to Mr. Ajami, Assistant Director, WRD. Assistant Director. इसका टेक्निकल सेक्शन नहीं है. This बोलना कि I'd like to welcome Ajamina, Assistant Director, WRD. ठीक है. उसका खत्म होने के बाद then संजीव बत्रा. इसका टेक्निकल सेक्शन है. ये उसका CV है. ये पत्रा. दो चार लाइन बोलना. Work set NHPC. एक इंजीनियर क्वेश्चन. ठीक है. Work at yeah. ठीक है. ठीक है. अजय ठीक. अभी दो ही लोग.
Welcome to another chapter of Practice Talks. In a way, this is an extremely critical topic. Since we talk about one of the basic survival needs of humanity. Modern societies need water for so many purposes, for domestic, commercial, industrial, and agricultural usage. Our water resources can be widely segmented into two categories: surface water and groundwater. Their efficient management has emerged as a critical and immediate need for India. Uneven distribution of water poses a grave problem for our nation. That is where the Bureau of Indian Standards has been playing a critical role by setting standards to follow through its Water Resources Department. Let's first hear from Mr. R.K. Jain, who is also holding the post of Chairman CWC. He will acquaint us with the importance of setting standards in this domain.
Standardization is very important for not only bringing uniformity in the procedures, but also to have quality control. Congratulate BIS for striving hard in formulating the standards. It is very important for any country to have its own standards, particularly in the field of water resources, depending upon local geography and other local conditions. Subject of water resources covers aspects like irrigation, drinking water, water for industrial use, planning and design of water resources projects, forestry issues, environmental issues, etc. Standards are needed for wholesome and organized development of any nation and also to resolve conflicts. There are 18 sectional committees in the Water Resources Irrigation Council, WRDC in short. These committees are playing a vital role in this endeavor BIS. WRDC advises new subject areas to be taken up for formulation of standards, keeping in view the national needs and priorities. It also advises on the matters relating to R&D needed for the establishment of the standards or their revision.
Let us hear from a senior BIS official on how standards are developed and the overall working of the technical committees.
The Water Resources Department has formulated over 450 standards. Over hundreds of experts put their heads together in this extensive consultative process of standard formulation, which is based on transparency, consensus building among stakeholders. The areas of work under Water Resources Department can be broadly categorized into surface water resources, groundwater investigation and management, river training works, and planning and management of water resources projects. Surface water resources is a big focus area. Within that, we work on dams and its appurtenances, such as spillways, weirs, gates, etc. We also work on reservoirs, lakes, and canals, instrumentation of hydraulic structures, and geological investigations. Another important category pertains to river training works, covering structures like embankments, groins, revetments, etc. Lastly, we deal with standards on management of water resources projects. Here we developed standards such as progress report and completion report of River Valley project. We also formulate safety codes in construction, operation, and maintenance of River Valley projects. Beyond this, we also work on subjects such as estimating unit rate for civil works, etc.
Now that we know the functional aspects of how the technical committees operates, let's take a closer look at their areas of operation. Dams, barrages, and weirs are man-made barrier structures built across a stream or a river that stops and regulates the flow of water in controlled fashion. Indian standards ensure that dams built in India are safe, economical, and durable, and are fit and functional to serve the nation. Let's hear about this in detail from our expert.
Let's talk about the Indian standards for dams and canals in our country. IS 6512. This is one of the important standards which gives the design criteria for any solid gravity dam. Design analysis is a crucial part for any dam before its construction. We understand that this stability analysis takes into account the several critical load combinations. The standard gives 7 different load combinations for it. They are mainly the dead load, reservoir and tailwater loads, uplift pressure, earthquake forces, earth and
welcome back all. Now, welcome back all after the high tea session. Now, I would like to invite Ajay Meena, Assistant Director, WRD BIS, for the presentation. Yes.
Presentation, no?
For the presentation of overview of standardization at WRD BIS.
Yeah, good morning, everyone. All the distinguished experts, and I extend my warm welcome to the professors from UBC and irrigation engineers from Karnataka government. And together, let's embark a journey of our knowledge exchange and innovation for a sustainable and prosperous future of our country. I'm Ajay Meena, Assistant Director at Bureau of Indian Standards, and I will be giving a brief presentation on the how standardization department of in BIS, Water Resource Department is working. Sorry for the technical glitch. दिख नहीं रहा 50 Okay, till then I due to the
Presentation is not moving and audio also is not audible. No?
audio is not audible now. Is it audible now?
No. Whatever he is speaking, only action is coming. That's all. And the presentation also only first slide is the standardization.
It not started yet actually. Am I audible?
Audio is clear.
To the online members.
Yes,
you are
audio
audible.
is clear.
You are audible, but whatever he is presenting, no, he is
Okay,
speaking
there's
something.
a technical glitch, so it was a delay. Now it will be started. Okay, the slide is changing now, no? To the online members.
No presentation. No presentation is visible.
प्रेजेंटेशन नहीं दिख रहा उनको.
और अजय मीना जी का वॉइस भी नहीं है.
Is it audible now? Actually, there is a technical glitch here, so that is why it is delaying. Just wait for 5 minutes, please.
Okay.
नहीं ये है मेरे पास. Till then, we can discuss that what is the standardization process and the basic definitions till the technical person was making this available. So standard development is the solution to our basic need, our daily routine problems. If we there are multiple problems we faced in construction, in water resource department, in any other in everywhere in every place. Like here is there are multiple products out here, like say projector, say this wooden table. Everything is standardized. If it is not standardized, then you cannot like there will be chaos everywhere. So this is the like the basic need of standardization here. To the online person, is it visible now?
Yeah, it is visible. It is visible now.
It is moving already, no?
Moving, yes.
Okay, okay.
Make it full screen.
Okay, make it full screen, please. Okay. It seems like it will not be they will not be able to make it full screen. So standards are in India, the Indian standards are the one which are approved by the national standard body, that is Bureau of Indian Standards. There are multiple bodies in India that they standardize the thing, but the if it is called the Indian standard, then it is approved by the Bureau of Indian Standard. So standards usually go unnoticed. Like standards are we work on standards when a problem is identified. So sometimes the severe lack of standardization got the same severe consequences due to that. So this workshop is all about this, that we are here to sensitize the irrigation engineers of water resource department of government of Karnataka. So we find out that we will find out that the standard should not go unnoticed, and the can you, it will not be zoom out, right? Zoom in. So standard. So standard and their significance, we already talked about that. If there is no standard on a product, then it will be chaos everywhere. Like for the manufacturer and for the consumers, for everyone, for every stakeholder. So this is the need of the standardization. So objective of standards are that is need based, and if there is a best practice, and if there is scientific innovation, and my voice is echoing, right? So update and upgrade our practices with the international standards, protect the interest of the consumers, even industries, and establishing a benchmark for a safety of goods and products and any code of practices. So what are the principle of standardization? There is a ISO standard, ISO code 59 that was published in 2019. They give the 5 principle of standardization: transparency. There is a section committee in every department of BIS, and that is there to formulate the standards. So transparency is required as it should be used by the all over India. So all over India is the stakeholder. So there is a need of transparency over here. Openness, the standard development program or work should be open to all. Every stakeholders should be there to give their view in this process. Impartiality and consensus. Standards are made for everyone in every stakeholders, and they should not be favor anyone. So there should be a strong need of maintaining the impartiality and consensus. Effectiveness and relevance. It should be effective in that to solve that problems for which the standard is created. Coherences, and in coherences there are multiple standard body in India, so there should not be any duplication of Indian standards or any slide is ending. Okay. So, slide is changing. So what do we aim for? We are aiming for making our standardization process more robust, making more quality standard, and identify more and more problems and make a standard to solve them. Tomorrow we have the urban flooding seminar. So this is because we identify a problem that there is a strong need of making a standard on urban flooding. So this is how we work. This is what our aim, just to eliminate the problems, eliminate the causes of the problems. So a standard is needed, very much needed in these things. So a standard must be needed, and it should be completed timely, and it should be using the current available best practices and acceptable to every stakeholders, and it should be the based on the consensus. So this is the standard space. It is there are international standards, there are regional standards for the regional problems, there are national standards for all over all over nations, and for there are association or industry specific standards. So stakeholders in national standard development, the standard ecosystem, that is, the stakeholders are industries, organizations, the universities, and the common public as well. So there are 16 division council in Bureau of Indian Standards, and Water Resource Division Council is one of them. These division council are the one which define the scope of the section committees, that assign the work to section committees, that in this scope you have to work. This is the standard development process. A common man, a common organization, any organization of India can give a new work item proposal to Bureau of Indian Standards, or to division council, or even to section committees. The section committees meet and discuss on the new work item proposal. If it agrees, then they will make a first draft. This first draft will be discussed among the committee members only, and the committee members will comment on this, and this comment will be incorporated, and again it will circulate it to the committee members. So this is called the pre-draft, that is preliminary draft. So after preliminary draft, it is again circulated to the committee members. Committee members comment, and if they satisfy that this draft is in good shape, and then we circulate it is WC draft, that is wide circulation. Wide circulation draft is available on the public domain. Anyone, any common person, any organization, any professor, anyone can comment on this, and these comment are resolved in the meeting of the section committee. And if section committee agrees on these comment and these resolutions, then it is a finalized draft will be prepared. And finalized draft is just after the approval of the division council chairperson, it is considered, it will be published as the Indian standards. So this is the brief process. This is the same. There are for the P draft and for the new work item proposal, that is the proposal stage, then it is the preliminary stage, and then committee stage and all. This is similar to the ISO standard body. So review of Indian standards through action research best approach. So every standard is subjected to revision for in every 5 years, just to take the technological advancement that has done within 5 years. And we know that the electrical section is booming up, and there is a lot more innovation. So in that case, we have made it 3 years. Like the electrical code is to be revised within in every 3 years. So reviews, we already discussed that reviews to incorporate the latest technological development, and if there is a new innovation or the problem is got another solution. So effective and relevance due to consideration of latest technological development and periodic review, which is 5 years in our case. And outcome of review, if we review a standard, then there are 4 outcomes. Reaffirmation, that if there is no technological or scientific development in that standards, then we just simply reaffirm that standard, that which are the old one. Amendment and reaffirmation. In this case, if there is a clause or some part of the technology got some technical advancement, then we just revise that particular clause of the standards. And then is similar. Another one is revision. There, if the involving the routine procedure of the new project, if it means that the whole of the process is just got some technological advancement. Withdrawal is if there is a standard which we do not have any need right now. There are standards that moving boat methods we measure the velocity. So there are few these standards just have the few benefits to it is a very basic standard, because there are advanced standards like current meter and all things. So if there is a need arise, we can withdraw these kind of standards. So this is the scope of Water Resource Division Council. We work, this division council work till on the water resources till it is to be given to the municipal corporation, or like up to the drinking water. We are not making the standards on drinking water. We are just till the part that that is to be distributed for the drinking water, and we are in our scope that electronic projects and dam safety and river training works and all things. So this is the complete hydrological cycle of water: evaporation, transpiration, condensation, precipitation, and all things. Water Resource Department at international level, we have 7P membership in different technical committees of IS organization, and in which we have 3 secretariat with India. Water Resource Department, that is ISO TC 113 hydrometry. It is the chairmanship and secretariat with India. Water Resource Department is handling this. ISO TC 113 SC1, that is velocity area method. We also have the secretariat and convener of this session committee with India. ISO TC 113 SC8 flow measurement structures, that is secretariat. United Kingdom has the secretariat of this. ISO TC 113 SC5 instrument, equipment and data management. The China have the secretariat of this. ISO TC 113 SC6 sediment transportation. India again have the secretariat of this. And TC 113 SC8 groundwater, that is South Korea having the secretariat. TC 339 small hydropower plants. It is a newly formed committee, just like formed in last 2 years, and China have the secretariat of this, and India. We have to comment. We are we have obligations to comment on this in these standards. And there is a observer status. We have 5 observers, 5 committees that we have 5 observer status. Okay. So there are 17 sectional committee, and that our DDG sir announced that there are 4 more sectional committees to be formulated, and that is urban flooding and small hydropower plant, etc. So there are 17 sectional committees on each topics, that hydrometry, groundwater, geological investigations, water resource planning management, and formation of foundation treatment and dam safety and these things. So program of work of a section committee define that it is similar to the division council scope. The division council direct to the section committees that these are the works that section committee has to do, and this, or based on that direction, each section committee have a program of work. So you can find this program of work from this link, that whichever standards are met by these section committees. So WRD1, that is the hydrometry. So this is the also called National Mirror Committee on International Standards, that is ISO TC 113 hydrometry. So this is responsible for the making the standards of the measurement of water resources. These are the list of important standards formulated by hydrometry section committee. Then WRD3 groundwater investigation. This is the mirror committee for the international committee ISO TC 113 SCR, in which India has a P membership, and it is standardized the aspects of groundwater resources related to investigations and water harvesting and recharging of groundwater. These are the important standards formulated by this section committee. And WRD5 is geological investigation and subsurface exploration. This committee is responsible for the ISO TC 319, that is on karst topography. It is also an international committee in which India has the observer status. So this is responsible for the making geological investigation, subsurface exploration related standards. In later half, Mr. Ajay Kumar Nathani will give you the brief on important standards made by this committee. So these are the list of Indian standards formulated by this committee. WRD6, that is water resource planning and management and evaluation. This is responsible for the water resource planning, development and management status. So these are the standards formulated by water resource planning, and you can access these standards by going. There is I think in comment section there is a link shared by the our DDG sir. You can go through this and you can find the Indian standards, or either you can directly Google search the program of work water resource department. You can get this list. So WRD8, that is foundation and foundation treatment. So standardization of criteria for design and construction of foundations, rocks, impermeable and permeable strata of water resources. These are the list of Indian standards formulated by this section committee. Dams and spillway related to various type of dam and spillway. These are important standards. And reservoir, and like similarly we have section committees that I earlier shown you. WRD12 hydraulic gates and walls, and WRD13 canal and cross drainage works, 14 for water conductor system, 15 for hydroelectric powerhouse structures. As an expert, you can find out these section committees, and if you have some new work item proposal, you just directly send us to wrd@bis.gov.in, and the section committee will taking care of that. These are the important standards formulated by this. So these are all the section committees, and this is WRD28 coastal water management. It is also newly formulated section committee, which was formulated in maybe in 2022 to taking care of the coastal erosion and this kind of work, that because it was the need of our that there was an study from 1990s to 2021. There was a study that in West Bengal around in West Bengal coast, 40% of coast in area has been eroded. So this basis on these kind of problems, we formulated the section committee. So these are the Manak Manch and all things which are initiated by the BIS to reach out our stakeholders. And this is the Know Your Standard tab. You can go to this website, and this tab will be open, and you can directly search your Indian standards there. Thank you for this.
Thank you, Ajay Meena sir, for your presentation, which was informative and clear instruction on how to achieve the goal. Next, I would like to invite Shri Sandeep Batra, Executive Director, Civil, NHPC.
There is some interaction. Some response. So that any doubts, feel free to give. Please. Please.
Yeah. So this is for question and answer session on based on my PPT. So if anyone having a doubt or any like how to download the standards or how to contribute into the water resource department standards, you can question. Yes, sir.
Yeah, please. My name is B.V. Subbarao.
Yes, sir.
I work in the area of water, particularly in the urban hydrology. I was wondering, we have very good standards for the structures.
Mhm.
I see these days I am coming across problems of placement of new projects near the irrigation structures.
Okay.
Do we have any standard that what is the minimum safe distance from the toe region of minor, medium and mega projects?
Yes, sir. For these kind of things are deal by the WRD 24, that is on environment impact assessment. So in this is also the newly formulated committee. So we are making a standard based on the projects. So in this section committee, the environment impact assessment is to be taken care of.
Yeah, thank you. But these days, environment impact assessment is dumped in the dustbin. Recently, I have a case where 75 feet from the toe region of a medium irrigation structure, a underground mining is sanctioned.
But sanctioning is the other part. This is not dealt by Bureau of Indian Standards.
No, but safe distance.
Yes.
See, safe distance from our structure. You have a standard for constructing the structure, but if you do not come out with standards of safeguarding the structures, we are facing problems across the country, sir. Please look into it.
Yes,
Okay?
sir.
This is only my suggestion. Thank you, sir.
Thank you for your suggestion, sir. These kind of things are dealt with the environment impact assessment, and there are standards, that product standards which are mandatory. In these case, we can enforce the standards, but if it is advisory nature, we can just advise. And what you are talking about, that the safe distance and guidelines, that is to be taken care by the Ministry of Environment and Forest. So if they issue a guideline, then that is the only enforceable. We are advisory in this case. Yes, later on we can discuss. Any other person have?
Please. Question is degree. Answer is of degree. Please. It's about the opportunity to raise such issues with have larger consequences. The consequences of environmental, ecological, sociological, cultural, etc., etc. So what I would like to say is, let this be noted down.
Yes.
These issues are there. This is only a symptom,
Mhm.
sample. So it's not like, it should not be like anybody, everybody, and nobody. Today, being a member of a technical committee, I want to say these symptoms should be grasped and try to find solutions. Because as you know, water management is like Draupadi, having 5 husbands. It's a fact of life. In all the lakes and other water resources, there are so many agencies. So I want to stop at that. Kindly take this as a response. And you are right in saying that WRD 24 is exclusively there to look at these issues. Next one, please. Any
So
question?
this is the purpose of this kind of events, that we can reach out to our list stakeholders and go to their views.
And I want to request all the participants here to give a applause because one people's representative from Malakal MLP here. Thank you very much, sir. He has come here. That shows the interest he's showing, and he's from the nativity of Professor Inayatullah. Personal touch always matters. Thank you very much for making us so gracious on this occasion, sir. Thank you, sir.
Thank you very much, sir.
And also, career qualifiers. So nice. Sir, you can definitely talk. ನೀವು ಕನ್ನಡದಲ್ಲೇ ಮಾತಾಡ್ಬೋದು. ನೀರಿನ ಬಗ್ಗೆ. So, any more questions, please?
One, two questions ಕೇಳ್ಬೋದಲ್ಲ?
Let you come, sir. Please.
Thank you,
Anyone
sir.
of you having any observations, questions, queries? If there are no questions, I can just tell you visit Manak website. There's a wealth of info. I found it myself. Whether it's national, SNAP, the National Standardization Action Plan.
Yes.
22 to 27. I don't know how many of you can make a career in it. As rightly pointed out by Ajay Meena, international representation is there. 5 committees, India is a observer status.
Yeah, and 3 we have secretariat.
Definitely can make a career. The enriched old ones also can find a place interacting with these WRD committees. Thank you very much. Sir, if there are no questions from the audience, I request Professor Deshankar sir have got some of this.
So it's a very nice deliberation from Ajay Meena sir, Assistant Director WRD BIS. I have a important question that nowadays we are talking about leaving the treated wastewater into the groundwater system. So this is right. I don't say it's wrong or something, but there should be some specific guidelines from the BIS, which I feel it is lacking. So for example, even the simplest fact that the virus travel in the earth environment, right? What should be the distance, right? That should be 200 meters. I know that, but it's not mentioned in BIS. So please note that right now, right, even the COVID genome, right, has traveled, right, because of wastewater, the treated wastewater being let into, the Australian this ground system. So these things have to be taken with seriousness, because in days to come, we have even so many things like radioactivity, everything. So it's good that we are, we ourselves we are doing, right? Kormangla Chalgata Valley, we are doing the tertiary treatment and leaving it to Kolar. All the Kolar lakes are filled. Everyone is happy. But what about tomorrow? Right? What about tomorrow, and what about the groundwater? So this specification, right, could be taken seriously, because it affects the human life and the aquatic life also.
Sir, WRD 3 groundwater and related investigation, on which I am the member secretary of that, and we already taking this standard, that is IS 15797, and we are developing a filter which it is on groundwater recharge. So we are making a filter so that the rainwater and any other water can be directly filtered and entered. After the filtration, it can enter to the groundwater. So we are already working on it, and it will be in wide circulation. You can comment on that in like next 3 or 4 months.
So very nice, very nice.
Thank you, sir.
Okay, that's very nice. Just to mention, 2 weeks back, WHO conducted a webinar on the COVID, virus transmission. You'll be surprised to know wastewater treatment plants are becoming indicators of COVID transmission. Very civil engineer, very WHO. You see, that is how the things are integrated. It's only passing the friends. Thank you very much, Ajay Meena. So kind of.
Thank you, sir.
And now I am.
Thank you. Thank you, Meena. And myself and our Jagannath sir also, the technical committee members of BIS. And also we are going to conduct similar programs, and where we need more inputs from you, both in construction industry, quality of water, of the using wastewater, what should be the qualities, the standardizations, many such programs we are going to do today, tomorrow, means in coming events. Now we are having a very, our guest, honorable guest, Mr. N.I. Gopal Krishna ji sir. He is a MLA, 7-time MLA from Malkalmuru, from Ballari, from Hudigi. Sir, I am also from Malkalmuru. We studied everything from him, and we are welcoming you, sir. And he is a deputy speaker of. What is it? Deputy, welcoming you, sir. And since deputy speaker.
No, sir. Thank you very much, sir. That's all right. I don't like it. Sir, it is actually for the people of this constituency.
ನಾವು ಆ ಲೆವೆಲ್ಗೆ ಅಲ್ಲ.
ಇಲ್ಲ, ನಿಮ್ಮ ಸಾಕು. ಇಲ್ಲ, ನಿಮ್ಮ ಕ್ಷೇತ್ರ ಜನತೆ ಬಗ್ಗೆ ಪರವಾಗಿ ಸರ್, ನಿಮಗೆಲ್ಲ ಇದೆ. ಪರವಾಗಿ ತಗೋಬೇಕು. ಥ್ಯಾಂಕ್ ಯು ಸರ್. 7 ವರ್ಷದ ಅನುಭವ ಒಂದು 4 ಪಾಯಿಂಟ್ ಇರುತ್ತೆ ಇಂಜಿನಿಯರ್ಸ್ಗಳಿಗೆ. ಇವೆಲ್ಲ ಇಂಜಿನಿಯರ್ಸ್.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಬಹಳ ಅನಿರೀಕ್ಷಿತ ದಾರಿಗೆ ಹೋಗೋನ್ ಕರ್ಕೊಂಡು ಬಂದು ಈ ಮಧ್ಯದಲ್ಲಿ ಬಿಟ್ಟಂಗಾಯ್ತು. ನನಗೆ ಸಮುದ್ರದಲ್ಲಿ ದೋಣಿಯಲ್ಲಿ ಕರ್ಕೊಂಡು ಹೋಗಿ ದೋಣಿ ಬಿಟ್ಟು ಹೋಗಂತ ಸಂದರ್ಭದಲ್ಲಿ ನದಿಯಲ್ಲಿ ಬಿಟ್ಟು ಏನು ಒದ್ದಾಡಬೇಕು ಆ ಥರನೇ ಒದ್ದಾಡಂತ ಪರಿಸ್ಥಿತಿ ನನಗಾಗಿದೆ. ಈಗ ನಾನು ಇಂಜಿನಿಯರು ಅಲ್ಲ, ಬೇರೆ ಈ ಸಬ್ಜೆಕ್ಟ್ ಸಂಬಂಧಪಟ್ಟಿರ್ತಕ್ಕಂಥ ಇಶ್ಯೂಸ್ನಲ್ಲಿ ಎಕ್ಸ್ಪರ್ಟು ಅಲ್ಲ. ಭಾಳ ಅನಿರೀಕ್ಷಕ. ಅದರಲ್ಲಿ ಮುಖ್ಯವಾಗಿ ನಮ್ಮ ಸ್ನೇಹಿತರು ಆಲಿಯವರು ಮತ್ತು ನಮ್ಮ ಸ್ನೇಹಿತರು ಇನಾಯತುಲ್ಲವರು, ಆಮೇಲೆ ಇನ್ನೊಬ್ಬ ಸ್ನೇಹಿತರು ಕೂಡ ಎಲ್ಲ ಮೊಳಕಾಲ್ಮೂರಿನವ್ರು ಅಂತೇಳಿ ನಾನು ಇಲ್ಲಿ ಕರೆದಾಗ ಏನೋ ಕಾಫಿ ಬಿಸ್ಕೆಟ್ ಕೊಡ್ತಾರೇನೋ ಅಂತ ಬಂದೆ. ನಾನು ಇಲ್ಲಿ ಬಂದಮೇಲೆ ಸಬ್ಜೆಕ್ಟೇ ಬೇರೆ ಆಯಿತು. ಭಾಳ ಖುಷಿ ಆಯ್ತು ನಿಮ್ಮ ಉದ್ದದಲ್ಲಿ. ಆದರೆ ನಿಮಗೆ ನಾನು ಹೇಳ್ಕೊಡೋಷ್ಟು ಪಾಠ ನಾನು ಕಲ್ತಿಲ್ಲ. ನಾನು ಸುಮಾರು 7 ವರ್ಷಗಳಿಂದ ನಾನು 7 ಸಾರಿ ML ಆಗಿರ್ತಕ್ಕಂಥವ್ನು. ಬಳ್ಳಾರಿ ಜಿಲ್ಲೆಯಲ್ಲಿ ಬಳ್ಳಾರಿ ರೂರಲಲ್ಲಿ ML ಆಗಿ, ತದನಂತರ ಮತ್ತೆ ನಾನು ವಿಜಯನಗರ ಜಿಲ್ಲೆಯಲ್ಲಿ ಕೂಡ್ಲಿಗೆಯಲ್ಲಿ ಕ್ಷೇತ್ರ ಶಾಸಕನಾಗಿ 4 ಸಾರಿ ಮೊಳಕಾಲ್ಮೂರು ಕ್ಷೇತ್ರ ಕೂಡ ನಾನು ಪ್ರತಿನಿಧಿಸಿದ್ದೀನಿ. ನಾನು ಚಿತ್ರದುರ್ಗ ಜಿಲ್ಲೆಯವನಾಗಿ ಕೂಡ ಮಧ್ಯ ಕರ್ನಾಟಕ ಬರ್ತಕ್ಕಂಥ ಭಾಳ ಹಿಂದುಳಿದಿರ್ತಕ್ಕಂಥ ಪ್ರದೇಶ ಅದು. ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ನೀರಾವರಿ ಯೋಜನೆಗಳು, ಅಲ್ಲಿರ್ತಕ್ಕಂಥ ನೀರಾವರಿಗೆ ಸಂಬಂಧಪಟ್ಟಿರ್ತಕ್ಕಂಥ ಈ ರೈತಾಪಿ ಸಮೂಹ ನೋಡಿದ್ರೆ ನಿಜವಾಗ್ಲೂ ಕೂಡ ಭಾಳಷ್ಟು ಕೂಡ ಈ ದೇಶದಲ್ಲೇ ನಡೆಯೋದಿಲ್ಲ ಅನ್ನೋ ಅಂಥ ಪರಿಸ್ಥಿತಿಗಳು ಅಲ್ಲಿ ನಡೀತಾ ಇದೆ. ಈಗ ಯಾವುದೋ ನದಿ ಮೂಲ ಆಗಲಿ, ನಮಗೆ ಯಾವುದೋ ಈ ಡ್ಯಾಮ್ಗಳ ಮೂಲಕ ಬರ್ತಕ್ಕಂಥ ನೀರಾವರಿ ಯೋಜನೆಗಳು ಅಲ್ಲಿಲ್ಲ. ಹಿಂದೆ ವಾಟರ್ ಶೆಡ್ ಸ್ಕೀಮ್ನಲ್ಲಿ NC ಮುನಿಯಪ್ಪನವರು ಇಲ್ಲಿ ಒಬ್ಬ ಕಮಿಷನರ್ ಆಗಿದ್ದರು ಅಗ್ರಿಕಲ್ಚರ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಗೆ. ಅವ್ರು ತಗೊಂಡಿರ್ತಕ್ಕಂಥ ನಿರ್ಧಾರದ ಹಿನ್ನೆಲೆಯಲ್ಲಿ ಸರ್ಕಾರದವ್ರು ಕೂಡ ಹೆಚ್ಚಿನ ಉಚ್ಚೇರ್ಣೆ ಕೊಟ್ಟು ಈಗ ಪ್ರತಿ ಹಳ್ಳಿಗಳಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಇರ್ರೆಸ್ಪೆಕ್ಟ್ ಆಫ್ ದಿ ಕಮ್ಯುನಿಟಿ, ಇರ್ರೆಸ್ಪೆಕ್ಟ್ ಆಫ್ ದಿ ಏರಿಯಾ, ಆಮೇಲೆ ಈ ಶ್ರೀಮಂತಿಗೆ ಬಡತನ ಇಲ್ದಲೆ ಆ ದೃಷ್ಟಿಯಿಂದ ಈ ಬದುಗಳನ್ನು ಮಾಡ್ತಕ್ಕಂಥದ್ದು, ನೀರಾವರಿ ಯೋಜನೆಗಳಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ನೀರಿನ ಅಂಶವನ್ನು ತಡೆಗಟ್ಟತಕ್ಕಂಥದ್ದು, ಅದರಿಂದ ಅಂತರ್ಜಲ ಹೆಚ್ಚಾಗ್ತಕ್ಕಂಥ ಒಂದು ಸಂದರ್ಭ. ಅಂತರ್ಜಲದಿಂದ ನಮ್ಗೆ ಎಷ್ಟು ವರ್ಷಗಳ ಕಾಲ ನೀರು ಬರುತ್ತೆ ಅನ್ನೋದು ಒಂದು ಭಾಳ ಮುಖ್ಯ. ಈಗ ಬರ್ತಕ್ಕಂಥ ನೀರೆಲ್ಲ ಹರಿದು ಹೋಗ್ತಕ್ಕಂಥ ಸಂದರ್ಭನೇ ಇಲ್ಲ. ನದಿಗೆ ಸೇರಬೇಕು, ಇಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಚಿಕ್ಕದೊಂದು ರಿವರ್ಗೋ ಅಥವಾ ಇನ್ಯಾವುದೋ ಒಂದು ಉದ್ದೇಶದಿಂದ ವೇಸ್ಟ್ ಆಗ್ತದಂತವೆ. ಈ ವೇಸ್ಟ್ ಆಗ್ತಕ್ಕಂಥ ನೀರನ್ನ ತಡೆಗಟ್ಟು ಹಿನ್ನೆಲೆಯಲ್ಲಿ ವಾಟರ್ ಶೆಡ್ ಪ್ರೋಗ್ರಾಮ್ನಿಂದ ಅಲ್ಲಲ್ಲಿ ಬೋತುಗಳು, ಚಿಕ್ಕ ಅಣೆಕಟ್ಟುಗಳು, ಡ್ಯಾಮ್ಗಳು ಕಟ್ತಕ್ಕಂಥ ಕೆಲಸ ಮಾಡೋದ್ರಿಂದ ಈಗ ಕೆಲವು ಕಡೆ ಎಲ್ಲ ಸ್ವಲ್ಪ ಆದಷ್ಟು ಅದರಿಂದ ನಿಜವಾಗ್ಲೂ ಕೂಡ ಅನುಕೂಲ ಆಗಿದೆ. ಈ ಒಂದು ಪರಿಸ್ಥಿತಿಯಲ್ಲಿ ಕೂಡ ಈಗಿನ ಪರಿಸ್ಥಿತಿಯಲ್ಲಿ ಈಗ ಮಳೆ ಬೆಳೆಗಳು ಈ ಥರ ಆಗೋದ್ರಿಂದ ನಮಗೆ ಭಾಳ ಕುಂಠಿತವಾಗಿರ್ತಕ್ಕಂಥ ಈ ಮಳೆಯ ಕಾರಣದಿಂದಾಗಿ ಈಗ ಭಾಳಷ್ಟು ಜನ ನಾವು ಅನುಭವಿಸ್ತಕ್ಕಂಥ ಸಂದರ್ಭಗಳಿದ್ದಾವೆ. ಈ ಕಾರಣದಿಂದ ನಾನು ಹೇಳ್ತಕ್ಕಂಥದ್ದು ಏನಂದರೆ, ವಾಟರ್ ಶೆಡ್ ಪ್ರೋಗ್ರಾಮ್ನಲ್ಲಿ ಈಗ ಏನು ಸೆನ್ಸಿಟಿವೈಸೇಷನ್ ಅಂತ ಈ ಕಾರ್ಯಕ್ರಮ ಮಾಡಿದ್ದಾರೆ, ಎಸ್ಪೆಷಲಿ ಫಾರ್ ಇಂಜಿನಿಯರಿಂಗ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ನವ್ರಿಗೆ, ಇಂಜಿನಿಯರಿಂಗ್ ಸ್ಟೂಡೆಂಟ್ಸ್ಗೂ ಮತ್ತು ಇಂಜಿನಿಯರಿಂಗ್ ಅಧಿಕಾರಿಗಳು ಕೊಡ್ತಾ ಇದ್ದಾರೆ. ಅದನ್ನು ಮನಮುಟ್ಟುವಂತೆ ಮಾಡಿರ್ತಕ್ಕಂಥ ಕೆಲಸ ವೇದಿಕೆ ಇರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಸೈಂಟಿಸ್ಟ್ಗಳು ದೊಡ್ಡವರೆಲ್ಲ ಸೇರಿದ್ದಾರೆ. ಅವ್ರ ಮಧ್ಯದಲ್ಲಿ ಕೂತು ಮಾತಾಡ್ತಕ್ಕಂಥ ಯೋಗ್ಯತೆ ನನಗಿಲ್ಲ. ಐ ಆಮ್ ವೆರಿ ಸ್ಮಾಲ್ ಮ್ಯಾನ್. ಅದ್ರ ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ರೆಸ್ ಮಾಡೋಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ. ಮೊದಲೇ ನನಗೆ ಹೇಳಿದ್ರೆ ನಾನು ಕೂಡ ಆ ಸಾಲಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಕೇಳಿದ್ರೆ ನನಗೂ ಉಪಯೋಗ ಆಗ್ತಿತ್ತೇನೋ ರಾಜಕೀಯ ಜೀವನದಲ್ಲಿ ಅಂದ್ಕೊಂಡೆ. ನೀವು ನೇರವಾಗಿ ಇಲ್ಲಿ ಕರೆಸಿರೋದ್ರಿಂದ ನಾನೇನು ತಿಳ್ಕೊಳಕ್ಕೂ ಆಗ್ತಕ್ಕಂಥ ಸಂದರ್ಭಗಳು ಇಲ್ಲಿ ಆಗಿದ್ದಾವೆ. ಒಳ್ಳೆ ಪ್ರೋಗ್ರಾಮ್ ಕೊಡ್ತಾ ಇದ್ರಿ. ಪ್ರೋಗ್ರಾಮ್ ಯಾವತ್ತೂ ಕೂಡ ಚಿರಂತವಾಗಿರಲಿ, ನಡೀತಾ ಇರಲಿ. ಸರ್ಕಾರದಿಂದ ಆಗಬೇಕಾಗಿರ್ತಕ್ಕಂಥ ಏನಾದರೂ ಅನುಕೂಲಗಳು ನಿಮ್ಮಲ್ಲಿ ನಮ್ಮ ಕಡೆಗೆ ಏನಾದರೂ ಕೊಟ್ಟರೆ, ಮಾನ್ಯ ಮುಖ್ಯಮಂತ್ರಿಗಳು ಸಿದ್ದರಾಮಯ್ಯನವರು ಒಳ್ಳೆ ಮಂತ್ರಿಗಳಾಗಿದ್ದರಿಂದ ಇರಿಗೇಷನ್ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಕೂಡ ಹೆಚ್ಚಿನ ಅವ್ರು ಬೆಂಬಲ ಕೊಡೋದ್ರಿಂದ ಮುಂದೆ ನೀರಾವರಿ ಯೋಜನೆಗಳನ್ನು ಯಾವ ರೀತಿ ತಗೋಬೇಕು, ನೀರಿನಿಂದ ಆಗ್ತಕ್ಕಂಥ ಉಪಯೋಗಗಳು ಏನಾಗ್ತವೆ, ಅದು ಎಷ್ಟು ಮಟ್ಟಿಗೆ ನಮ್ಮ ನೀರಿನ ಯೋಜನೆಗಳಿಂದ ರೈತರಿಗೆ ಅನುಕೂಲ ಆಗುತ್ತೆ, ಇರಿಗೇಷನ್ ಪ್ರಾಜೆಕ್ಟ್ಸ್ ಯಾವ ರೀತಿ ಮಾಡಬೇಕು ಅನ್ನೋ ಭಾವನೆಗಳಿಂದ ನಾವು ಮಾಡಬೇಕಾಗ್ತದೆ ಅಂತೇಳಿ ನನ್ನ ಭಾವನೆ. ಹೀಗಾಗಿ ಇವಾಗ ನನಗೂ ಭಾಳ ಅನಿರೀಕ್ಷಿತವಾಗಿ ಕರೆಸಿ ನನಗೆ ಭಾಳ ನಿಜವಾಗ್ಲೂ ಕೂಡ ದೊಡ್ಡ ಸನ್ಮಾನನೆ ಮಾಡಿದರೆ ಅಂದರೆ ಅತಿಶಯೋಕ್ತಿ ಆಗಲ್ಲ. ನಿಮಗೆಲ್ಲರಿಗೂ ನಾನು ಋಣಿಯಾಗಿರ್ತೀನಿ ಅಂತ ಈ ಸಂದರ್ಭದಲ್ಲಿ ಹೇಳಿ, ನಾನು ML ಆಗಿದ್ದೀನಿ ಅಷ್ಟೇ, ನಾನೇನು ಮಂತ್ರಿ ಆಗಿಲ್ಲ. ನಾನು ML ಆಗಿರ್ತಕ್ಕಂಥವನ್ನೇ ಕರೆದು ಇಷ್ಟು ಮಟ್ಟಿಗೆ ನೀವು ನನಗೆ ಗೌರವ ಕೊಡ್ತೀರಿ ಅಂದರೆ ಮಂತ್ರಿಗಳಾಗಿ ಬಂದಿರಿ ಇನ್ನೆಷ್ಟು ಗೌರವ ಕೊಡ್ತಿದ್ರು. ಸರ್ಕಾರದಿಂದ ಆಗ್ತಕ್ಕಂಥ ಲಾಭ್ಯಗಳನ್ನು ಸೌಲಭ್ಯಗಳನ್ನು ಹೆಚ್ಚಿನ ರೀತಿಯಲ್ಲಿ ನಾವೆಲ್ಲ ಪಡ್ಕೊಳ್ಳೋಣ. ಈಗ ಏನು ಕಂಡಕ್ಟ್ ಮಾಡ್ತಾರೆ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಎಲ್ಲ ಒಳ್ಳೆ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಎಲ್ಲ, ಸೈಂಟಿಸ್ಟ್ ಇದ್ದಾರೆ, ಎಕ್ಸ್ಪರ್ಟ್ಸ್ ಇದ್ದಾರೆ, ಒಳ್ಳೆಯ ವಾಗ್ಮಿಗಳಿದ್ದಾರೆ. ಇವ್ರು ಹೇಳ್ತಕ್ಕಂಥ ಪ್ರತಿ ಅಂಶದಲ್ಲಿ ಪ್ರತಿ ವಾಕ್ಯದಲ್ಲಿ ಕೂಡ ಮನಗಾಳ್ತಕ್ಕಂಥದ್ದು, ಅದು ನಮಗೆ ಅದ್ಭುತಪೂರ್ವಕವಾಗಿರ್ತಕ್ಕಂಥ ವಿದ್ಯೆ ಅಂತೇಳಿ ನಾವು ತಿಳ್ಕೊಂಡು ಅವ್ರನ್ನ ಫಾಲೋ ಮಾಡಿದ್ರೆ ಭಾಳ ಒಳ್ಳೆಯದು ಅಂತೇಳಿ ನನ್ನ ಅಭಿಪ್ರಾಯ. ಮಾತಾಡ್ಲಿಕ್ಕೆ ಅವಕಾಶ ಮಾಡಿಕೊಟ್ಟಿದ್ರಿ. ಮೊದಲೇ ಹೇಳಿದ್ರೆ ನಾನು ಸ್ವಲ್ಪ ಹೇಳ್ಕೊಂಡು ಬರ್ತಾ ಇದ್ದು விசாரங்கள் ಏನು ಗೊತ್ತಿಲ್ಲ.
ஜியோ எனக்கு முடிய போகுதா, வேற என்னெல்லாம்
ನಮಸ್ಕಾರ.
அனுப்பியா ஃப்ரீயா இருந்தேன்னா மெசேஜ் ஒரு பார்த்து எனக்கு அனுப்ப முடிஞ்சா. வர அவசரம் இல்லை, எதுவும் அனுப்பினாலும் நான் பார்க்குறேன். அதே ஸ்கீம் இருந்தா பெட்டர்.
Friends, since sir spoke in Kannada, I will try to make it 1 minute summary. Primarily, sir was focusing on being an MLA for 7 consecutive times. He is focusing on going for groundwater recharge, has enhanced the groundwater potential. And that gives an indication there are very good number of best practices which we as engineers interested in standardization should look at. That's point number 1. Point number 2, the humility with which he is participating. I can tell you, friends, even the United Nations Intergovernmental Panel on Climate Change says polity is the biggest gap. Political decision is the biggest gap. Sir has got such humility to take the best of the experience we share as scientists, as academicians, as researchers. That's the second take home. The third and the foremost, most important, the last one is that shows that the program we are doing, there's a lot of expectation. We need to be serious and we need to pitch in. Everybody, so what next? So everybody has got responsibility, all stakeholders. Sir, we will take these 3 points from your visionary speech. It need not be a orator like articulation is not required. But these are the 3 points I could pick. There could be many. Sir, many thanks for coming, because this is beamed all over in the virtual program. Thank you, sir. With that, kindly take over.
Next, I would like to invite Shri Sandeep Batra, Executive Director, NHP, for a technical session. A short brief about Shri Sandeep Batra is a graduate of civil engineering with an all-round of 33 years of experience in hydropower sector. He has handled contracts, costing and planning functions at NHPC at regional as well as corporate level. He has also handled operations and maintenance of 2 power stations, namely Siwa 2 power station in Jammu and Kashmir and Chamira 2 power station in Himachal Pradesh. Now I would like to invite for the seminar.
डिपार्टमेंट को वापस अभी आया नहीं है। कोई बात नहीं, आने दो। मेरे ख्याल से DRC का क्या है, वो एक्सपोर्ट वगैरह चेंज करना मुश्किल होगा, कुछ ऐसा कुछ लिखा। मैं देखता हूँ, आने दो पहले। पहले क्या मैं देखता हूँ, पहले क्या था, कौन था, मैं देखते हैं, उसी को फॉलो करना पड़ेगा।
I'll have to deliver my speech in English because Kannada probably I
देखते हैं, वही आने दो।
Amma Bangalore, so we want that.
मैं अपने रूम में बैठा हूँ।
The program is standards for water resources and sensitization of irrigation engineers. So first, we have to understand importance of standards.
नहीं वो तो ठीक.
Why standards? Standards are so vital that if you don't have standards, modern civilization is not possible. Growth of science is not possible. And there will be chaos. And I'll be explaining it. Means unless we standardize basic things like measures of weight, length, and time, no science is possible, no progress is possible. So these starts from there, means standards start from there. And if they are not there, then how chaos happens, means there are few very fundamental things which you all have experienced that maybe if you have traveled outside India or even within India, you can see that there are multiple sockets for plugging and drawing power from the wires for electricity. And everybody struggles with that. You go from one country to other, you have to have a different plug. And this should be standardized. And once it is standardized, a lot of hassle, a lot of problem is solved. Vehicles with right-hand drive and left-hand drive. I sincerely hope that it all means left-hand drive and right-hand drive itself. That too needs standardization. So it will again save a lot of hassle. And we were facing a lot of problem because of multiple port types for charging of mobile phones till recently. So you will see wires hanging, 5 or 6 types of wires hanging everywhere at airport, at malls. And again, if all the mobiles have the same port, so once you buy a cable, that works for all. So again, standardization is important. It saves, it makes economic progress possible, and it does many other benefits, as we will see going forward in the presentation. How can we go forward? Green. Yeah. Standardization happens when the stakeholders decide that yes, these are the goods that we are manufacturing, or this is the service that we are delivering, and we all come together and we agree through some regulatory mechanism, through some mandate, or through consensus and consent of all the stakeholders, that these are the frameworks that we are going to follow to prepare this good or service, or to deliver this service. So once that happens, once everybody agrees, again through regulatory mechanism or through consensus. So that is what standardization is, why it is required, we will see forward. And standardization happened over the period, means when people found that if we don't standardize things, we have problems. So probably India was the first one in Indus Valley civilization. We find the signs that they had standard measures for weights. If it is not there, then you will not know how much quantity you have bought, whether it is vegetable, whether it is grains, whether it is anything else. How many milliliters of oil you have bought. Unless there are measures for that, it will be very difficult to always get the same quantity for same amount of money or barter. So it starts from there. So Indus Valley civilization realized that, and they tried to make, again, it may not be as accurate as we have right now, that how much will be 1 kilogram or how long will be 1 meter. They may not be having that accurate, but they were trying to at least this is the weight almost this much, which everybody will get if they give this much in barter. So later on, as the civilization was growing elsewhere, there was an architect who used to make plans for buildings. He realized that there is no standardization. Means when I talk of buildings, if you don't have standards for how much high the slab will be, you will find, and at many old buildings, you will find that it is at very inconvenient height, the slab that we have in kitchen. Or for that matter, many other things. I can give you example because I'm a civil engineer, so I can give you probably 50 examples of that. So he tried to, in his own way, in those initial years, he wrote a book, De Architectura Permitas Utilitas Venecertas, means the structure should be solid, it should have usefulness, and it should also have beauty, since he was architect. A big thing came in the form of Magna Carta in England. The king declared that citizens will have some rights. It was a charter of rights of citizens. And one of the clause in that was in year 1215, more than 800 years back, that there should be standards so that my citizens get service without getting cheated. So if standards are not there, he realized that people are being cheated. They pay for something, they get something, because we are not making standards. So realization came slowly, and later on came industrial revolution, when we started producing a lot of things in Europe. And at that time, if you don't standardize, everybody is making his own design, and they are not conforming to each other. Again, chaos. So that's why as industrial revolution progressed, standardization also progressed. There was Sir Joseph Whitworth, who realized that everybody is making screw at different pitches. So the nuts and bolts don't fit. So let there be a standard for it. So that all industries are making nuts and bolts and making screws at pitches when they conform to each other. Otherwise, there will be 100 types of screws and nuts and bolts. There was again Sir John Wolt Barry, who realized that we are using a lot of iron and steel, and we need to have standards in this industry. Means these are slowly the industries which are getting recognized that unless we have standards, we realize later on. Means in Europe, how national bodies start coming up. We had our body in 1946, it was decided. In 1947, this came up. Earlier, it used to be called, if you old timers will remember, ISI. The BSI was originally ISI. So still we have ISI mark. So in Europe, in Britain, 1901, when they had their body. And recently, telecommunication had boomed. Means there will be industries, new industries coming up, which were not there earlier. Means I have seen computer in my lifetime coming. Otherwise, in India, there was no word like computer. So there will be progress, there will be new things, and there will be new standards always. So telecommunication was booming. So it was realized that across the world, if we don't have uniformity, the product made in one country cannot work in another country. So like the 5G, which is happening right now. So nobody is agreeing on standards. China says that my standard should work. Europe says its own. America says its own. So a lot of tussle. Because everybody, that again is an issue with standards. Every country wants that their way of manufacturing should get recognized, or their standards should get recognized at world level. That's why SNAP 1 and SNAP 2 has come. That we don't have any say. We have been following standards of America, of Britain, of Europe, of Japan, of even Australia. But we didn't have any say there. I mean, in ISO or IEC. So now, slowly, India is also a voice there. We are participating, as was told, that participating member and observing member in many of the committees there. Japan took lead in Asia in 45, but we were not very far. In 46, we also had our meeting, and in 47, it was a government body was made, which will be our national standards body. I'm telling you all this history because sensitization means that you understand that why standards are important. And once we realize that why they are important, then we will start implementing them. Then we will, before taking up a work, if there is a code for that, we'll go to that code, we will read that, and then we will design that structure. Right? So that's how best practices get formed up and become standards. Then there were many bodies, means national bodies of standards. At one stage, it was realized that even internationally, they have to cooperate. The standards have to be standards at international level, not at national level. So that's how ISO came into being, International Organization for Standards. ISO is short form of ISOS, which means equal. Equal means everyone is having a level playing field, having same standards across the world. So this happened in 1946, and the body came probably in 47 again. And yes, it is very important that now it's a global village. So we have to have standards across the countries, one standard for things, so that there is less chaos. Again, as I told that in 47, it came into being. 46, it was decided. 47, it came into being. And Lal C. Varman, if you go to BIS office, probably there is a bust of him. And he is the pioneer who set the pace. And what we see in whatever form we see BIS now, it is through those baby steps that we have come here. And Lal C. Varman is considered the pioneer in India, and his bust is right in front of the main building of ISI. Later on, it was changed into Bureau of Indian Standards in 1987. It was decided in 86 in Parliament that it will now be called BIS, and from 1st April 1987, we call it BIS. The certification mark is still ISI, because older things had ISI marks, so now newer things BIS. To avoid the confusion, probably it was decided that let's continue with that design of marking. So it is considered very important at government level. Minister of Cabinet Minister as well as Minister of State, various consumer bodies, scientific bodies, government, central and state, they all are part of it. And we have various committees, various councils, and within councils, various committees. It's a huge endeavor. Quality certification and marking is a separate issue. Making standards is a separate issue. We are concentrating on how standards are developed. So, as I was saying, that economic growth is affected if things are being developed in haphazard manner and ad hocism. Standardization avoid a lot of wastage also. They give you direction that this is the way now things will be done. Right. Again, a small example, if floppy size was not standardized and each country was having its own floppy size, so you go from your country and your floppy doesn't work there. Later on, if you are having CDs and each country was having a different diameter of CD, so your CD will not work there, or his CD is bigger, now you cannot insert it. So again, even for small things, we don't realize that somewhere, somehow, standardizations were made. And there were, again, at times, fight between Japan and America. Somebody is making Blu-ray, somebody is making something else. Sony has developed one technology. European companies have developed another technology. America has developed. So now they all are fighting that my product is better. And some of the time, even here, what happens is might is right. The best product loses out to people who are little stronger. That also happens many a times. One important aspect of standardization is that it improves the quality of life, right? Especially in electrical products. If standards are not maintained and people get electric shocks and they die out of it, or if ISI standard says that this is the minimum quality that is required in the product, if that minimum quality is not defined and any industrialist can dump anything into the market, means who will be the loser? The consumer will be loser. And again, now a lot of sensitivity is there for environmental protection. So standards also take care of things that when you are producing things or when you are delivering a service, environment is taken care of. And then BIS is working on capacity building. This again is a part of probably SNAP initiative and capacity building that we are here to sensitize. It is being, sensitization is happening in colleges, with students, in academics, in industries, even at, you will be surprised to know, even at school level. So there is a policy of BIS that if students form a committee over there and they get grant from BIS. If a school has formed that committee, they'll get some money to hold periodic meetings and discuss things. So all levels are being sensitized and being involved in the process of standardization. Again, SNAP I will not go through because I was traveling and I have come directly here. Probably the previous sessions may have covered some aspects of it. Now probably we are into second SNAP. So 22 to 27, and there are 7-8 focus areas there. I believe means there will be further talks also, and Meena ji talked about it, and other speakers from BIS may have talked about it. I'll rather skip through it. We'll come to water. That why standards are required. Why standards are required in water? Water as a resource. Water, what thing can be more important? I cannot think of. Means in India, if I use Hindi, which is my language, we call Jal hi Jeevan. Water is life. If you don't have water for some time, means health will start deteriorating like anything. And if you have bad water, polluted water, again, a lot of problem, because we are more than 70% water, in fact. So water is that important. Apart from that, if they can put the slides up, yeah. Previous. Again, water cycle means this is natural. It is happening every day, all the time. Hydrological cycle doesn't stop. It is a continuous process. It's being shown there, but not there. So I wouldn't know what is running. Should I come there with the? Oh, it is. How we utilize water as a resource? Agriculture, since time immemorial, when we started, human beings started the farming, and irrigation requirements were there. So agriculture requirement is there, domestic requirement is there, household, no household can run without water. And those who have shortage of water, they understand how important it is. Since we have abundance, probably in many areas, tap water is there and we just open and we get it. Many people travel a lot to get a little amount of water. So household, very important, drinking water, very important. Industrial processes, many of them, almost all of them need water. Recreational use of water, navigation for a very long time, means now we have other means of transport. At one time, this used to be the main means of, because it used to be the cheapest and easiest when roads were not there, when we had not invented balloons or aeroplanes or helicopters. So water used to be the best way of transportation. And then one important, it has power, because hydrological cycle is continuous. Water is being, evaporation is happening. It is going into atmosphere in the form of clouds and other forms, and it precipitates over mountains. So automatically God is giving us energy in that form. Energy of sun is getting converted into potential energy of water. So that we can harness. So for all this harnessing of water as a resource, again we need standards. Again we need standards for what will be the potable water for households and drinking, what will be the quality of water for industrial usage in various industries. Slides, can we put, or should I come there so that I can see this slide? Can I get this one? How much time have I left? I will wind it up. Speaker doesn't have track of time. This. Yeah, those are various uses of water, and many of the usages need fresh water. That is the importance of fresh water. You'll realize that we have abundance of saline water in ocean, but that is not of much use as of now. So again, fresh water is very limited. That again is a requirement when we make standards, that wastage of water doesn't happen in various processes. And what is most important is water is a natural resource. And now we have started calling it a renewable resource, because wind is renewable, solar is renewable. We have to realize that hydrological cycle is continuous. So water as a resource is also renewable. The rivers will have water always, because the cycle is happening every time. This is the cycle again from, you can see evaporation happens and it goes in the form of clouds and precipitation, and again water comes into aquifers, in lakes, in streams. This is what hydrological cycle is in short. Next, please. I will rather run through because probably I am taking more time. This slide again tells that how much little fresh water we have, which we utilize every day. But water is not as abundant as it appears, because ocean water is of no use right now to us. So usable water is very little. If you see this blue gets extended into this, again that blue gets extended into it, and very little of that is usable. If you will see the rivers and lakes, probably you can use well, little bit groundwater, but rest of it again is difficult to harness. Not that it is impossible, but difficult to harness. It will be costly. Again, because life will exist only when water is there. And although right now it appears that we have water, as the population growth will happen, as industrial growth will happen, it will become scarce. That limited water will have to be shared by everyone. So that's why we have to avoid wastage of water. It's beautiful, it's powerful, but at the same time, it has so much power. We can utilize that power for our own benefit. A big part of electricity that we get here comes from hydropower. Most of it comes from, more of it comes from coal, because we as country have a lot of coal. but a large part of it comes from hydropower. And initially it used to come only from hydropower in India. So it's that important. But when that power creates havoc, then again it's a big problem. So tomorrow we are having a seminar on urban flooding. Urban flooding is dangerous and difficult to handle, but then any flooding for that matter is very difficult to handle. And there are much bigger events like GLOF, glacial lake outburst, which recently happened. If probably we all must have read in newspaper in Sikkim. So it's that huge. So we have to try to limit the destructive capabilities of water, and we have to use it for the benefit of mankind in various forms. So that is the purpose of developing water as resources and having standards for that. Again, since recently Sikkim happened, before that Uttarakhand, Nanda Devi happened, and whole Chamoli belt and all those districts got affected. In urban flooding, Kerala happened, Bombay every year problem is there, Chennai happened. I believe in Bangalore also there must be areas. When you are not taking care of these things at planning stage, right? Urban planning is a field. If you take care of these things at the planning stage and if you make standards for it, the job is much easier. And the other way is don't think, develop in low-lying area, don't assess that how much inflow can happen there, don't see how much drainage you are creating, or if at all you are creating, whether pumps are required, whether natural drainage through gravity is possible in that area. Means if all these things are thought of at the time of planning and there are standards for that, you save a lot of hassle, lot of cost that you are going to incur at later stage. You will obviate all those costs because you planned well. So that again means if you make standards, then a lot of things can be saved. And I will not go through details. These are a few photographs that in Kerala, that beautiful town area changes into this. And recently in Sikkim, a beautiful dam was producing 1200 megawatt, and now it is zero. Because a glacial lake burst, which was staying there for 2 years. One day that moraine had to move and give way. So since that sensitivity was not there, it could not be taken care of, and one day nature showed its strength. And this is Uttarakhand again. What happened in Nanda Devi GLOF event, not GLOF event, in fact, a lot of glacial mass came into the valley, got accumulated and then moved. You can even call it GLOF also. Urban flooding, we are having a seminar tomorrow, probably we'll skip this. I don't think I have much time. I may have taken, yes. So this year has gone through. We have up to WRD 28, but committees are 17 in this sectional committees in this Water Resource Development Council. They have made a lot of standards. I am part of such committee also, and I am heading WRD 23. I'm chairman of that. So that is my association with BIS. Basically, I am a hydro engineer. Again, Mr. Meena has told that we are also active in water resources at international level. There are committees in which we are participating members. Even we have secretariat with us. We are convener as well as secretariat, which is a prestigious thing that you are heading that committee. In many of the committees, China is having secretariat. In many of the committees, other developed countries are having secretariat. But we also have a say now. We make our presence felt there. In many of them, we are observing members. Again, all those 17 sectional committees, what they do, probably if I had time, we would have gone into that. Then we would have seen a lot of them are relevant for your area of work also. It's not that in these 17 only canal committee is concerning you. There will be many others where you will have interface. So out of these 17, probably I should say even 10 of them, maybe in some way or the other, at one time or the other, maybe corrected with the irrigation work as a whole. Because you also have to make a diversion structure or impounding structure. You also have to make intakes. You also at times have to make water conductor systems or canals and majors and minors and distributaries and everything. Means that one particular is there, but all other things, these geological investigations may be required at times. Subsurface investigations may be required. So a lot of them can be relevant. So we all should be sensitive that which area we are working in and what are the standards there, and we should search for them in the on that site itself. So we can, now things are very accessible. At one time you had to have a library and search there, and if there is a standard at all. But now such keywords are there, just search it and you know that whether a standard exists and try to work according to that. Maybe you will get some insight and you will know about best practices, how that work can be done better. So I'll probably rest here because I don't know how much time I have taken. So thank you.
Question. Any audience would like to ask some questions? Sandeep sir.
Yeah. My name is Nayak Wadi. I am retired MD of a electricity distribution company. Because you are from hydro generation, etc., I thought it is relevant to ask you a question. The per capita consumption of electricity in India is about 1,000 units. But per capita consumption of electricity in China, it is 2,000. In US, it is 8,000. When we study all this, electricity is the basic prime mover for any industrial development in any country, whatever it is. But when are we going to catch up China or go beyond that? With our present installed capacity, half of the capacity of China. In your opinion, when we are likely to increase the generation capacity so that abundant electricity is available to the people of India? These are always questions. Last 50 years, we have been struggling, but we are not able to make headway. In your opinion and experience, how do you look at the situation and what are your suggestions? Thank you.
As you have rightly said, sir, that this is also a measure of the quality of life that we are having. Means in developed countries, it is not even 8,000. Some of the countries are having more than 10,000, 12,000, even 14,000. More developed a country, better lifestyle people are having there. Means it may be a smaller country, but very rich, and people are having better lifestyle. They are probably even at 14,000. So as country develops, as country grows, the demand of electricity will increase, right? It all depends on the development. Means how much industries you are having. China is having a lot of manufacturing. They are now the manufacturers of the world in a way. So a lot of electricity is being consumed there. Not so much industrialization here. There was no access to electricity to a large section of population few years back. Many of the villages were not even connected. So where was the demand? So how can we match their per capita? There, every household has electricity all the time. Here, if at all we connect a village, then how many hours we are able to give electricity? So that also is a question. So there is suppressed demand also. Right now we say that we are almost meeting our, not meeting exactly, means the shortages are much less. What they were 20 years back or 30 years back, 40 years back. But government knows that demand is going to increase. We are going to develop. We are on the way to become a developed nation one day. So a lot of now, a lot of capacity is coming in solar. The realization is that coal is not such a good way of generating electricity. It is highly polluting because you are burning right away fossil fuel. Right away, you are creating carbon dioxide, monoxide, sulfur dioxide, nitrogen oxide, nitrogen dioxide, all kinds of gases and particulate material. So all old plants are very polluting. So they are being phased out. Unfortunately, only hydro, solar and wind is not able to meet the projected requirements. So still some thermal is coming up, but with much better technology. But better technology is very costly and India still has minimum limited resources. But we are working on developing our installed capacity. Right now we have in excess of 400 on paper, but we are able to meet demand of some 215, 20 megawatt, gigawatt peak. Later on means 500 gigawatt we are going to have as per government projections of renewable only in 2030. And rest 300 probably will come from thermal, coal. So our installed capacity should be double of what it is now in 2030 because our per capita consumption will also increase and population loads will also increase. So at that time, we plan to have double of what the capacity that we have right now, 800 megawatt. And out of that, 500 will come from renewable, not from thermal, this coal or gas or anything, or lignite or anything. So those are the plans, and hopefully we'll get there. Thank you.
Any questions on water and sir regarding water? Water and irrigation and standard Indian standards. Our PWD and irrigation engineers are more here. So
as rightly pointed out by you. You see, always we were talking on installation and production power, but very little attention has been given on standardizing the distribution of the power. Even today, we have great losses in the distribution system. And some companies are improvising and coming out with, standardized. But I feel we should also focus in bringing out standards in the distribution sector. Thank you, sir.
any other?
Again, transition is happening in that direction also.
Yes.
Transition is happening in that direction also. Means very rightly said, what we call euphemism losses, large part of that is pilferage. So that again, everybody knows, government also knows. So how to curb that? The way is to incentivize better performance by states. Means the states which do well get more grant. Secondly, smart metering in a big way. Means government wants ki all meters should be smart now. And smart meters should not only be at the household level or industry level or the consumer point level, the feeder level and even higher level. Means how much power is going from this feeder. And then I know that my feeder is telling this much and my households are telling, yeah, my consumers are telling this. So this is the area which is a problem area. So even that area in a way gets penalized a little bit. That too can be a mechanism. But yes, if it comes to standardization, the meters should be smart. Technology is there. Today we have technology and it is easy. Means Internet of Things is the way of life right now. So all can be connected through internet. That's the way forward, I feel.
So we have a very good canal network in terms of around 5,000 kilometers from Almaty to up to Bangalore. So why should we plan regarding solar panel canal network? Even we have a thousands of acres of land in colonies, many things.
So floating solar is a very good thing because you don't need land for that, right? Land again is a resource, and if you put, it's easy to put solar plants in Bikaner, Jaisalmer, and Kutch area, but rest of the land is very valuable because for agriculture purpose or for even other purposes. So floating solar doesn't need any land. If you have large network of canals, then probably the department can think of floating solar. Floating solar is that you don't put panels on land. They are not land mounted, but they are mounted on the buoys, means on the floaters. So that technology is there, and a lot of countries are doing it. A lot of other states are doing it. Probably Karnataka state can also think of it. And we can be a partner in that if you want.
So now it's coming on the seas also. Coming on the sea. Yes. So only thing that I just want to close before we close, one single point is hydroelectric projects were not encouraged when we were students, but those students who are sitting here, hydroelectric projects are encouraged. This is the new change that has happened. Why? Because we are not constructing dams in the new strategy. For example, we have the biggest project on the Nepal border, right? Gandaki River project, Bihar-Nepal border, correct? So that is called the Run on the River project. I have a DST project on that, correct? So Run on the River projects are coming and no more dam construction, no more ecological this thing. So this is the new concept and therefore hydroelectricity, right? And even it could be multi-purpose and everything. So water and power are interrelated again. Thank you.
Sir, one thing. So since BS is involved in the framework and making policies and standardization, and as Minister said, it doesn't have any binding instructions on the organizations or agencies to implement. However, this is being certifying the agencies. Why can't it have some rules and frames for to make a policies or to penalize or the institutions which violate these standards? Since sir is in the technical committee, so it can be implemented.
I would like to take that question.
In some of the things, probably electrical products, I believe
Sir,
that if it is dangerous for public.
So since you are in the technical committee, like anything which violates the base standards, why cannot be made penalized or binding instructions? It can be irrigation, sir. Because since electrical, it's already the framework is there, but in the field of irrigation, like construction, those things. Yes, and no, it's not standardization. Apart from the standardization, you should have a binding framework and to penalize it, since it is a loss of resources, loss of only human life where it is requires. There is a framework to give the like to penalize it, but why not in other resources?
Again, it raises a fundamental question. Is standardization always a good thing? No, it is not. I am telling you, I am sitting in this conference on this side where I should be defending standards. I am telling you not. There are times when technology is evolving. And if you make very harsh standards, that kills creativity. Right? Right now, say we have already come a long way. It means we were developing AV equipment. So every scientist was trying to come up with his own way of doing things. Right? Slowly you realize that yes, we have come at that stage when too much of technology, various types of technology is creating a problem. And we have almost reached a level where technology has matured. And this appears to be the best way of moving forward. So then you standardize. At what stage you do standardization, right? So standardization and at initial stages, at all levels, is not right strategy at times. Okay, but you are very right, when consumer interests are involved, when people are being taken for a ride in the country by dumping substandard products on them, and they are even being made to pay for that in a good measure, and they are being dumped upon dangerous products or harmful products, harmful for their body, for environment, or dangerous for them. Children, toys for that matter. What product, what material to use for that? Or will they have edges? Will they be metal? Means accidents happen because of that, because there is no check on that. So there are certain things where to protect consumer interests and for the safety and for the environment, standards should come with penalization, right? But not in many other areas, probably standards should be there because they are telling us the best practice. People should follow them, try to follow them, but at times, if they are not following them in the sense ki little bit leeway is required, and it is not means in any way violating any law or harmful or anything, there are times when standards can be little flexible also. Standards are indicating the best practices. It will be good if you can follow it literally. But if you find that for your system, this one is suiting and you can prove it on your file or to your bosses or to the industry boss or anything, whoever is authority, then probably at that times, in those cases, in those areas, penalization is not required. So it depends. It's a thin line, but it depends. You have to decide.
So it depends on, like, we are publishing three types of standards: product standard and guidelines and code of practice. What you are talking about is that is the code of practice. You cannot like, enforce the code of practice because it develop over the times. So if there is a product, we can enforce by the on the advice of the ministry. Like sir rightly said about the toys. So we realize that the toys is harmful for the materials, can be harmful for the kids. So this is now enforceable, and it is under mandatory certifications. So this is enforceable, but in code of practice we cannot enforce. And even if some of the clause can be enforceable if the ministry advises.
Thank you, Batra Sahab. It was a very
Sir,
nice.
I have a specific question. I am S.A. Hussain from Water Satyagraha. It's a people's movement about scarcity of water, cost of water, quality of water, and how we can fulfill that. So I have a specific question with regard to the microplastics, sir. What are the standards with regard to microplastics in drinking water or packaged drinking water?
Very rightly pointed out, a very vital question, that whenever we drink bottled water from a plastic bottle, whether it is coming out of fridge or it is lying in our cars, in sunny, hot weather, means water, microplastic is getting into that water and then into our body. But since that is not my field, I wouldn't know the standards, if at all they are there. Yes, there should be. It's a dangerous thing and it's an area of concern. But I wouldn't know these standards because that is not my field.
Hello. Sir, this particular question is will be answered by another department of Bureau of Indian Standards. And this packaged drinking water is dealt by FAD division, food, and the bottle is under our another department. And this particular issue has been already taken up. Coming under certification.
So this taken by the food and agriculture.
Yes, we'll take up this issue, sir. Thank you.
Thank you, Sandeep Batra, sir, for your session and answers. I hope it was informative and clear. Next, I would like to invite Dr. V. Jagannatha, retired scientist engineer, ISRO. I would like to invite him to present a topic on standardization in reservoirs and lake sectional committee, WRD BIS.
Namo Bodhaya, Jai Bhim. My sincere thanks to Director WRD, Bhanu Prakash sir, and the BAS community. And I have been asked to conclude by 5 minutes. I don't think I require 5 minutes. Madam is waiting for me. She will going to lift her hand when it is 3 minutes. Then I'll close by 5 minutes. Because in Kannada there is a proverb, ಹೆಚ್ಚಿಗೆ ಮಾತಾಡಿದ್ರು ಆಯಾಸ ಕಡಿಮೆ, ಹೆಚ್ಚಿಗೆ ಮಾತು ಕೇಳಿದ್ರು ಆಯಾಸ ಕಡಿಮೆ ಅಂತ. Not only for me, for people who listen also. Be very careful. My PPTs are few. I think the system or the persons are not there, but I can make out because I'm a popular science activist, Vijnana Parichat. I can speak without any aid. See, the issue I'm supposed to talk is, what is our committee doing? Committee is doing some too many good things. Only yesterday, going whole night either way, I participated in a one-day training program for technical committee members. I found a wealth of information. A wealth of information. Sir Bhatta Sahab, hats off to you. You not only gave a historical perception, you gave what exactly is going on there. That's what I'm already have taken much of my time. I don't want to again indulge. What is happening is, sir, please run through the slides if you can. Otherwise, I'll summarize. I have a few points to share. Point number 1. Irrigation engineers, water resource engineers, please feel free at home. There's a deluge of information at manak.org. It's a website. There's a deluge of information on water. Point number 1 is clear. Point number 2, the process since 1945. Lal Saab, sir, I took a photo in front of Manak Bhavan 2 days back with Bhanu Prakash sir. I was so happy. It is true that we have got 22,000 plus codes, but they have not become part of the lifestyle of people in India. To a great extent in the production, yes. The manufacturing, yes. Even the hallmark of gold sale, you see, they have become sectorally relevant. The time has come to make it wholesome, enabling the community to take care of their health and the environment they live in. Second point over. Third point, last point. In so many questions I got about energy and all. At my home, since 14 years, I got a kitchen biogas plant. I was invited by United Nations University to Vietnam. I found both in cities and villages not linked, houses not linked to electricity or LPG. Vietnam. They're leaving. They're making it a way of life. 1875 to 1975, the human population increases 3 times. The primary energy consumption 32 times. 15% of the energy in the world is used by the internet, the so-called social media. Women don't get pregnant by using the mobile in the waste. I don't want to dwell upon further. You make it a way of life. Standard is there. Quality is there. So this energy bluffing is there, no? If you have more energy, country will develop. No way. No way. Please come out of it. I'm a student of Professor A.K. Reddy, who struggled for years together to tell where are Asuya Parastu Surya Shaka Namali. That is, Others should be envious. So much sun energy we have. At my home, I got solar and wind. At my home, I got wetland. I got at my home aerobic biodigester. It gives me so much of compost for my 120 plus grow bag terrace gardening. I don't want to go further. Please look at your lifestyle. To spit is awareness. To put a layer of soil on that is consciousness. We are lacking that. For engineers who are practicing, I'm my apology, because I taught you 30 years back as a lecturer. Today you are not following the guidelines of the best practices. The internet is used for something else, but you don't see in your own domain what is the best practice happening. I was talking with our Almaty friend. Such a wonderful case study he was sharing with us. Each one has got an enormous ability. Faraday did not go to school. Edison did not go to school. Both of them found the electricity and bulb. Nobel did not go to school, but he found gunpowder, and he gives Nobel Prize. And his company brought one of our prime minister down, Bofors gun. What is happening? Let us look at the best practices of our grandparents. I'll close by saying that I could locate the photo of my grandfather and mother, Uchamma and Timmaya, and pasted it in front of my home. Whenever I go myself or others come, I want to wash the hand and leg and come inside. Is the practice required. Each time a sincere Mohammedan, he goes to a mosque to pray, he washes his hands and legs, goes to the prayer. We go with a mobile to the temple. Earlier days, temples were there, they became theaters, then they became the TV, then they became the mobile. Now I wish genetic engineers integrate the mobile to the body so that there's no problem with the signal or the power. Let me say, the committee is doing wonderful work. We are able to review so many IS codes, and I look forward, as our co-guide my PhD. I'm a 66-year-old youngest research scholar, which our sir was also telling in the morning. See, point is, 88-year-old person in America has got third PhD, and one Agarwal in UK, Lucknow has got 2 MPhils at 92. So let me again say, this WRD is an opportunity for all of you to come forward. We'll be having year-long program. Please be a part of it. There could be a career for you. There could be a career for your future generation. Let us be positive. I'm not hopeless. I'm not hopeful, but I'm hopelessly hopeful. Thank you very much.
Thank you, Jagannath sir, for your short, insightful session. Finally, as an appreciation for the time and valuable input the presentations have given, so we will present a small memento for Ajay Meena sir. Next, Sandeep Batra sir. Lastly, Dr. V. Jagannatha sir. Now we shall all take a small break for lunch and be back assembled within 30 minutes. 20 minutes, sorry.
Food is ready. Food is ready. Lunch is ready. Yeah. No, lunch is ready. Please join for the lunch, and please gather here within 20 minutes. We will have a wonderful sessions in the afternoon. Already ಹೋಗ್ಬಿಟ್ಟು already announce ಆಯ್ತು lunch ಇರ್ತದೆ. ಸಾಕು ಎಲ್ಲೋ ಏನೋ ಕರ್ಕೊಂಡು ಹೋಗಿ ಏನೋ ಹೇಳಿ
Gopi. Idlo ka leka.
Hyderabad. ಈಗ ನೆಕ್ಸ್ಟ್ ನಾನು ಸರ್ ಫೆಬ್ರವರಿನಲ್ಲಿ ಕರಿತೀನಿ ಇಂಟರ್ನ್ಯಾಷನಲ್
ಬರ್ತಾ ಇದೆ ಅದು ನಮ್ಮ ಅಲ್ಲಿಂದ ಕೊಟ್ಟರೆ ಪಿಕ್ನಿಕ್ ಆಗ್ತಾ ಇದೆ ಬರ್ತಾ ಇದೆ ಅಲ್ಲಿಂದ ಪಿಕ್ನಿಕ್ ಆಗ್ತಾ ಇದೆ ಏನು ಬೇಡ फोटो चाहिए फोटो नहीं करना है
ನೋಡಿ ಇಲ್ಲಿ ಸುರೇಶ ಆಫ್ ಮಾಡು ಸೌಂಡ್.
ಗೋಪಿ ಗೋಪಿ
ಇಲ್ಲಿ ನಿಂತು ಕಾಣುತ್ತವೆ, ಇಲ್ಲಿ ನಿಂತು ಕಾಣುವುದಿಲ್ಲ. ಸರಿ, ಇದು ಗ್ಲಾಸ್ ಇದೆ ಎಲ್ಲ ಇಲ್ಲಿದು ಕಾಣೋದಿಲ್ಲ ಗ್ಲಾಸ್, ಬಿಕಾಸ್ ಆಫ್ ಗ್ಲಾಸ್. ಒಂದ್ ಕೆಲಸ ಮಾಡಿ ಜೀವ ಜೀವ ಹಿಂದ್ಗಡೆ ಆ ಎರಡನೇ ಇಲ್ಲಿ ಅಲ್ಲಿ ನಿಂತಿದ್ರೆ ಕಾಣುತ್ತೆ ನೋಡಿ, ಅಲ್ಲಿ ಅಲ್ಲಿ ಎರಡನೇದು ಇಲ್ಲಿ ಇಲ್ಲಿ ಒಳಗಡೆ ಒಳಗಡೆ ಎರಡನೇದು ಇಲ್ಲಿ ಇನ್ನೂ ಹಿಂದೆ ಅದು ಅಲ್ಲಿ ನಿಂತು ಕಾಣುತ್ತವೆ. ಪಕ್ಕ ಬೆಸ್ಟ್ ಕಾಣುತ್ತೆ ಇಲ್ಲಿಂದ. ಒಂದು ಲೈನ್ ಕೆಲಸ ಮಾಡಿ ಅಷ್ಟೇ. ಇಲ್ಲಾಂದ್ರೆ ಒಂದ್ ಕೆಲಸ ಮಾಡಿ, ಇಲ್ಲಿ ಕಾಣುತ್ತೆ ನೋಡಿ, ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇಲ್ಲಿ ಕಾಣುತ್ತೆ, ಇಲ್ಲಿ ಇದು ಬೆಸ್ಟ್ ಜಾಗ ಇದೆ ನೋಡಿ, ಇಲ್ಲಿಂದ ಕಾಣುತ್ತೆ. ಈ ಮೈಕ್ ಹೀಗಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಇಲ್ಲಿ ಕಾಣುತ್ತೆ, ಇಲ್ಲಿ ಕಾಣುತ್ತೆ ಜೀವ ಎದುರಿಗೆ. ತರಿಸ್ಬಿಡಿ ಫಸ್ಟ್ ಟಿವಿ ಮತ್ತೆ ಒಂದು ಸ್ಟ್ಯಾಂಡ್ ತರಿಸಿ, 40 ತರಿಸಿ, ವಿಧಾನಸೌಧ ಗೇಟ್ ನಂಬರ್ 2 ಅಂತ ಹೇಳಿ. ಕೇಬಲ್ ಹಾಕ್ಬಿಡಿ ಇಲ್ಲಿ ತನಕೊಬ್ರು. ಕೇಬಲ್ ಹಾಕ್ಲಿಕ್ಕೆ ಎಷ್ಟು ಉದ್ದ, ಕೇಬಲ್ ಎಷ್ಟು ಉದ್ದ ಬೇಕು ಹೇಳಿ. ಏನೇನ್ ಬೇಕು ನೋಡಿ, ಆಮೇಲೆ ಟಿವಿ ಬಂದಿರುತ್ತೆ ಮತ್ತೇನಿಲ್ಲ ಅದಿಲ್ಲ ಹೇಳೋದ್ ಬಿಡ. ಕೋರ್ಮಂಗ್ಲಿಂದ ಬರ್ಬೇಕಾ? ಸ್ಪೀಡ್ ಆಗಿ ತಗೊಂಡ್ ಬರ್ಲಿಕ್ಕೆ ಹೇಳಿ ಓಡೋನಿಂದ. ಇಲ್ಲಿ ಯಾರ್ದು ಇಲ್ವಾ ಹತ್ರ? ಬರತ್ ಬಿಡಿ ನೋಡು. ಒಳ್ಳೆ ಟ್ರೈ ಮಾಡ್ಲಿಕ್ಕೆ ನಾನು ಲಾಸ್ಟ್ ಟ್ರೈ ಮಾಡಿದ್ದೇನೆ ನಾನು. ಬಂದು ಬರ್ತಾರೆ ಬೇಗ. ಬಂದ ಕೂಡಲೇ ಕಾಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಗೇಟ್ ನಂಬಿಟ್ಟು ಹೋಗಿ ಯಾರಾದ್ರೂ ಹೋಗಿ ಕರ್ಕೊಂಡು ಬರ್ಬೇಕು. ಅಲ್ಲಿ ತನಕ ಕೇಬಲ್ ಏನ್ ಬೇಕು ಅದು ಹೇಳಿ, ಲೆಂತ್ ಕೇಬಲ್ ಶಾರ್ಟ್ ಆಯ್ತು. ಜೀವ ಉದ್ದ ಕೇಬಲ್ ಎಷ್ಟು ಬೇಕೋ ನೋಡಿ, ಕೇಬಲ್. ಆಮೇಲೆ ಪವರ್ ಸಾಕೆಟ್, ಪವರ್ ಆಗ್ಬೇಕಲ್ಲ ಸಾಕೆಟ್, ಪವರ್ ಸಾಕೆಟು ಅದು ಹಾಕಿಡಿ. ಟಿವಿ ಬಂದು ಪ್ಲಗ್ ಮಾಡೋದು ಪ್ಲೇ ಮಾಡಬೇಕು. ಟಿವಿ ಬಂದ್ಮೇಲೆ ಕೇಬಲ್ ಹಾಕೋ, ಪವರ್ ಹಾಕೋ ಅಂತ ಹೇಳ್ತೀನಿ. ಇಲ್ಲಾಗ್ದು ಕರೆಕ್ಟ್ ಆಗತ್ತೆ ನೋಡಿ. ಮಾತಾಡ್ತಾ ಮಾತಾಡ್ತಾ ಇಲ್ಲಿ ಒಂದು ಕಣ್ಣಾದ್ರೂ ಈ ಕಡೆ ತಿರ್ಸ್ಬೋದು. ಏನ್ ಜೀವ, ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಒಂದ್ ಕಣ್ಣು ತಿರ್ಸ್ಬೋದು. ಇಲ್ಲೇ ನೋಡ್ಬೇಕಂತ ಇಲ್ಲ, ಇಲ್ಲಿ ಒಂದ್ ಕಣ್ಣು ಸಾಕಾಣತ್ತೆ.
ಯಾವ ಗೊತ್ತಾಗುತ್ತೆ ಚೆಕ್ ಮಾಡ್ತೀನಿ ಒಂದಿನ ಹಾಂ
कॉपी ये वो डेल कनेक्ट किया ना लैपटॉप पे फिर लैपटॉप में डाला है ना वो केबल लैपटॉप पे है हाँ क्या क्या बात है
ಅಂದ್ರೆ ಈ ಕಡೆ ಕಾಣೋದಿಲ್ಲ, ಇಲ್ಲಿಂತಾಗ ಇಲ್ಲಿ ಮಾತಾಡ್ತಾ ಒಂದ್ ಕಣ್ಣು ಈ ಕಡೆ ಇಟ್ಕೋಬಹುದು. ಇಲ್ಲಿ 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 ಡೌನ್, ಇಲ್ಲಿ ಮೇಡಮ್ ಡೌನ್, ಈ ಕಡೆ ಇದ್ರೆ ಈ ಕಡೆ ಬರ್ಬೇಕಾಗುತ್ತೆ. ಎಲ್ಲ ಹಾಕ್ಬೋದು ಮೈಕಲ್ಲಿ ಇದು. ಇವ ಮೇಡಮ್ ಹೇಳಿದ್ ಇಲ್ಲಿ ಹಾಕ್ಬಿಡಿ ಟಿವಿ, ಆಯ್ತಾ? ಇಲ್ಲಿ ಇಲ್ಲಿ ಆಯ್ತು ಮೇಡಮ್. ಅದು ಸ್ಟ್ಯಾಂಡ್ ಬರುತ್ತೆ.
Yes, sir. A brief introduction about the speaker. Mr. Sanjay Marwaha is currently working as a member with Haryana Water Resource Authority, Panchkula. He has retired as a member, Central Groundwater Board, Ministry of Jal Shakti, Government of India. His current assignment is regarding conservation, management, regulation of water in the state of Haryana. During past around 35 years of experience in the field of groundwater science, he was involved in various activities relating mapping and management of groundwater in India. Yes. This presentation will be online. Sir.
Thanks. Should I start the presentation? Hello. Okay. If I'm audible, it's fine. I hope I'm audible to the audience. Good
Yes, sir.
afternoon, everyone. Yeah, thank you. I'll be concentrating on this, my talk, regarding the role of BIS, Bureau of Indian Standards, with regard to the water and more precisely groundwater. Because, generally we can standardize any item which is visible to us, but it is very difficult to standardize those items which are not visible to us actually. And fortunately or unfortunately, groundwater is one of those subjects which is generally not visible, hence not given that much attention in any of the sciences and the forums. But because of the our country, our climatic conditions, even agroclimatic regions of the country, we are highly dependent on groundwater, and we are increasingly getting dependent on groundwater for various uses. Either it is for agriculture, for industry, for domestic, for use of the anything you think of which is not available directly, we depend on groundwater. Luckily, the groundwater, not luckily, unfortunately, groundwater is being considered as a secondary source of water than the surface water, which is generally available. But as one of the World Bank study has already indicated, it is one of the most dependable source and always acts as a drought proofing. Whenever there is very poor rainfall and whenever there is lesser water available in the dams, the people dig more tube wells, more wells to sustain their livelihood, to sustain even drinking water supplies. I think a city, those who belong to Karnataka, I can understand most of the engineers, they belong to Karnataka here, and they can actually understand the importance of this subject, though it is a little bit, sometimes appears to be a little bit vague. I can give you, when I was in, I took a voluntary retirement from Government of India as central part of the Central Groundwater Board, where I was working as a member there. And I was involved in the aquifer mapping. We were working on Karnataka very closely because, Karnataka, large areas of Karnataka are overexploited. So we need to know and develop some technologies and the methodologies, and then standardize those methodologies so that we can actually quantify or understand where water is available, how much quantity the groundwater is available, how much quantity can be easily extracted. One story goes from the Karnataka, I remember from those days, where there was a farm which was next to on the outskirts of the city Bangalore. One farmer, he took loan for growing trees. 100 trees he grew, and then he got little bit of water from a tube well. But when he started irrigating those, the tube well got dry. Then he took again loan. He sold off his wife's ornaments even to grow more plants in that area, and that also borewell went dry.
So if the water is not available in that area, we should not think of going deeper, going farther. I mean, the lateral extent, that also we need to take care of. So we have to be very methodological, very systematic while understanding this science. It's just like if somebody has a stomach problem, they go for an ultrasound, and only the doctor who does the ultrasound, he understands what is happening in your stomach, whether the intestine is having a problem, whether the pancreas or liver is whatsoever is the problem. So this also is an indirect science. So there need to be a methodology to understand. Again and again, I'm saying. So what are the methods? We are working very hard at the BIS to work on that. And I'm happy to share with all of you that our activities are, recognized at all levels, even in ISO. And they always appreciate some of the standards which have been, it's other way around in groundwater. Some of the standards which have been developed by BIS have been adopted by the ISO, they are the part of the ISO now. So that's a little bit importance of the groundwater. Why the standardization? I think this document everybody knows. This is a very important diagram, though everybody has shown this a water cycle. There is nothing great about that. We are reading or seeing this map or a graph or the pictorial representation of water since our third class or fourth class. But let's understand, there water is moving. Let's only think of where the groundwater is there. Let's talk about that only. There is the lakes, there is a water going, and this is going outflow into the sea and all this. Sometimes the lakes, evaporation comes and it comes back. This particular, again, it's just think always like this groundwater flow. We need to understand whether a person, like just these 4 trees are there. You think Bangalore is in the center of these trees. And if you drill here at say 300 feet, you may get a little water. But if you drill around 1,000 feet, you may get water. But if you go to 1,500 feet, you may not get water. So all these things one has to know, and what methodologies are to be adopted. We need to understand all those. At international level, everybody has seen we have the permanent and the observation level. These are the sectional committees. I'll not go detail into that. This is the first thing. Before we standardize anything, we need to know what are the definitions. But because once we define a thing, then we are concentrating at certain activities. The scope is defined. And once the scope is defined, we can go deeper into that activity and determine the methodologies accordingly. I'm coming straight away to the groundwater investigation. These are some of the standards which have been developed. There is basically the WRT 03. I was earlier the chairperson of this particular group. Recently we also represented BIS in 2 of the very important committees at ISO. One is with the South Korea. The chairperson is the South Korea now, and I'm really happy to announce that in 2 of the main committees, which were the reason. This is the main committee of which we are member. I'm talking about the TC 113 SC8, subcommittee 8, and some of the activities were identified, but the scope of this committee is so restricted that it's very difficult to enter into their domains. Though we have been very successful in the past to go for the artificial recharge to the guidelines, for which the ISO methodologies are there. They adopted this methodology, but it's very difficult to convince them that how much important is the groundwater. You know, some of the countries in the world, say European countries, primarily in the northern hemisphere, or the American countries, those who are completely laden by the snow for most part of the year, they don't feel pinch of it. And some of the areas like Netherlands, they have lot many water resources available with them. So the finding out a groundwater itself is not a big issue there. It's a very big issue with Indian subcontinent, where I'm not talking about Indian subcontinent, that's India actually. I should talk about. We had many water in the Indo-Gangetic alluvium in the north. Everybody thinks that there is so much. If Ganges is there, Yamuna river is there, there is so much of water. But the water is there in the rivers, but we are drawing much higher at rates, and the water levels are going down. So we need to understand what are the reasons, what are the forces which are occurring in that. So we need to have a standardization of all the aspects of the groundwater resources, related investigation, water harvesting and recharge. It covers most of the things which we try to address it. So what are the works which are list of the standards being worked is the groundwater harvesting. Everybody is doing, only yesterday I came to know even advocates are working on the groundwater harvesting. It's very good. I mean, let everybody do it, but don't dilute the science actually. Don't dilute the thinking process, that not all the aquifers, we need to identify the aquifers. Not all the aquifers, they can adapt or take the water at the rate. If there is an aquifer, at which rate it will take. I think once again, I'll quote the example of Bangalore, which is a quite large part of the Bangalore is being supplied groundwater from the wells and from the lakes which are situated outside. So we have to have the technique very clearly. Now I'll tell you, for example, in the Bangalore city itself, after 25th of August, because of the aquifers which are generally very compact with very slow rate of groundwater movement, the most of the wells, if somebody is from Bangalore, they can see for themselves that most of the wells are filled to the top. But that does not mean the groundwater has been filled. It is because of the capacity to take the water by the aquifer underlying your city is very less. It just varies from 1 to 3%. 1 to 3% means that the water which is in the rock, if the rock is of 100 cubic meter, only 1 cubic meter of water will travel inside. I mean, just I'm simplifying the things. So it's very less. And the moment what happens is, moment you enter into a month of March, this whole water goes dry. You see, oh, where this water has gone. No, it was never there actually. It was only a surface storage which you were seeing. So the groundwater harvesting has to be an area specific, has to be an aquifer specific, depending upon the rates of the aquifers, depending upon the conditions and the quality aspects. Everything is to be seen. Next point, what we are working is the geophysical logging of the borewells. There are so many agencies which are working in the field. They have multiple type of the equipments. So many techniques are there, geophysics logging I'm specifically talking about. But what is the standardization for these things? These are the area specific standardization. The standards which has been created in the Spain does not get validated in Indian conditions, because the rock types of Bangalore, of Delhi, or of Vishakhapatnam, Pune, Bombay, Mumbai, and all these are different. So as per the local rock type, we need to have the local methodologies which is valid for Indian conditions. Then aquifer mapping, which was initiated around 5-6 years ago by the government of India. They have already prepared many maps. Now we are going for the guidelines, how to do it. Once we know the guidelines, then we will come to know the utility of those. Then mathematical modeling of the groundwater. This is a purely a mathematical extension of the works which has been done. Many people are doing, and it's done across the globe very nicely. Surface runoff harvesting using small structures. We have, recently finalized this particular activity, and will be shortly, I think BAS will be floating the standards for public observations. My request is, whenever BA sends a letter to the Karnataka authority, there has to be a nodal officer who sees what are the mails which are coming to them, and please address to them, and please respond to that also. I remember that I was part of one of the ISO group for SHPs. So I requested the technical officers, because you are doing small hydro projects also in those areas, to become a part of that, the main committee also. So so many contributions the state governments can do. You can, similarly, the aquifer storage and recovery, the SSDs mean the subsurface dikes and the groundwater dams, groundwater and surface water interaction, role of springs in the water supply. The last is generally applicable in the northeast areas. But the groundwater dams, if you see at the subsurface dikes, lot many works you have done in Karwar areas and so many areas. But do we have a methodology how to do it, how to develop it, what are the reasons why we should do it? Because the reason, the main objective I can tell you is because of the underlying rock formation is such that it has to be permeable. It should not allow the vertical percolation, and which is the base flow after the rains. The water which can be stored more in those areas can be developed there, stored there, and utilized for a later period for the local population and the community involved. So all these activities needs to be very clearly defined, and these are some important activities as far as the groundwater is concerned. Now I'll tell you some of the other WRD groups where water or groundwater is actually directly have an impact on the engineering explorations, like the surveys for the ground geological investigations, because groundwater is hydrogeology. So hydrogeology means the water with respect to the geological conditions. This is pure geology and subsurface explorations. There is a sync or the overlap of little bit of these things. Like I'll tell you, the groundwater investigation for hydraulic structures, for gravity dams, for geophysical method and seismic refractions. So all these, and the last one is by the geophysical, by the electrical resistivity. So the concept is the same. Here we are finding out in the groundwater the current availability and disposition of the groundwater. But the objective or the methodology for this particular activity is little bit different, but we need to standardize that as per our local conditions. Similarly, water resource planning, until unless you don't have the groundwater knowledge, you cannot have the water resources planning in a holistic manner. So likewise, the current practices need to be identified. In any it's written like the river valley, even if there is no well demarcated watershed area, as in the Indo-Gangetic alluvium, northern part of the India, they don't have the very clear cut demarcation of the watersheds because of the area being more or less topographically there is not much variations. There are though, but on a macro scale there are so many rivers which the catchments have, like river Ganges is there, then Indus is there. So all these rivers, they contribute to the this, and then we need to take a holistic planning, like guidelines for the fixing of the intensity of the irrigation, rates for the irrigation water, planning and design of drainage, especially in the irrigation projects. In Haryana and Punjab, both states, there are lot many irrigation projects. The water is let by the surface water. It spoils the groundwater and the waterlogging comes. So we need to know, take out the water, what should be the designs. All these guidelines are there. And then the completed medium and minor irrigation projects also are with them. So similarly, the foundation, we should know the aquifers, where are the availabilities of these aquifers. That also a little bit linked with that. This is a new area, which is a new constituted committee. I like to introduce this because certain parts of Karnataka also are having the coastal areas on the western side specifically. So these standardizations, design, planning, construction of the management of the coastal water zones, the coastal pollution, coastal erosion, desalination, intake and outfalls, saltwater intrusion, remote sensing, estuary, hydraulics, backwater islands, coastal hazards, coastal structures, coastal aquifers, and submarine groundwater discharges. Submarine groundwater discharge is a very fascinating subject, which is a new project which was taken up by CWRDM and so many other organizations. Around 10 IITs, they got mixed. But we need to understand there is a lot many water which is available in the ground in your state, but going out of your area in one manner or another. Either it is going as a base flow, or it's going as the surface flows, or even going out of the system as submarine flow. We need to identify, but how do we identify them? Until unless we don't have a specified guidelines, specified this, else the things will go haywire, and ultimately will lead to same data, same information, but different type of interpretation. This should not happen. So with this, I thank you all for a patient hearing.
Oh, thank you, sir. Is there any questions from the audience if you want to ask to the speaker?
Thank you, Sri Sanjay Marwa.
Thank you, sir.
My question is, this rainwater harvesting, artificial recharging and all started only in the beginning of the 21st century. But the age-old lakes of India, like Hyderabad has around 4,000 lakes in and around the HMDA zone. I was always asking, my colleagues in the CGWB that what is the radius of influence of a 10 hectares lake in recharging the groundwater? You see, rainwater harvesting, individual things is a different thing. But whereas at systems level, from one department to the other, all the lakes are under the irrigation department. We can have some standardization of the things. Before that, we need to understand, because I take this liberty, Marwa. I'm a batchmate of Sushil Gupta. Okay. And my friend in 1988 filed a case in the High Court asking for the list of lakes, and court said, go to the urban development. He said, neither I am getting the list of lakes, nor I am getting information on the recharging capacity of 10 hectare lake. Interestingly, the same case reappeared in the High Court yesterday. Is it not the justice delayed? And my friend is on deathbed. And the departments where huge public money is flowing into, we are not looking at the systems approach, I'm unfortunate to say. We are only looking into the piecemeal approaches. Thank you, sir.
Right. I'll like to respond to a very interesting discussion. Rather, it's a more of a query. Sir, actually, if you see very closely, the groundwater, whenever we do any groundwater estimation of any watershed, we need to take care of all the water related structures so that we understand the recharge very well. Recently, groundwater resource estimation has de-linked, earlier it was done on the block level basis, it has de-linked the block and the urban area separately. So now the urban areas like in Haryana or in Delhi, they are being handled separately. It's very disheartening to note, but you have pointed out very nicely that there is in Hyderabad city, there are around, as you said, around 4,000 lakes are there. As a thumb rule in groundwater resource estimation, there is a method to know how much water is getting percolated inside. In the earlier estimation, it is depending upon the surface area, number of days and infiltration factor. There's no, it's a small science, not big activity. Or even if you don't have anything, then you have a thumb rule also for to do it. 50% of the water which is stored in a lake is contributed to the ground depending upon the local temperature and local climatic conditions also, but generally it is like that. And ultimately, when we talk about the thumb rule, we need to understand the underlying hydrogeology or the geological conditions which the aquifer will adapt, and then accordingly whether it will be having the more downward movement or the horizontal movement. These are the activity which each lake has to be studied and deciphered. It cannot be a generalized solution, but for a specific area generalized solution can be developed, and there is not it is not a big problem, but some activity can be done based on the piezometers which can be installed by the side of the lakes, and we can know whether they are contributing actually to this. I'll tell you an example, sir. We did a study. We were doing a work in the Delhi area, in JNU area, where similar rock types as the Hyderabad, they exist. There, what we observed in the first year of the recharge was as high as 97%. But only thing is, since the lot of silt which comes with the water, it clogs the openings of the aquifers. We need to scrape it and we need to clean it, and that is the maintenance which will enhance the recharge rate if the lake is constructed for recharging purpose. But some of the lakes or some of the water conservation structures are constructed for extracting or pumping that water out of that system. So we need to have there we do not want a recharge. We actually use a plastic clay or a plastic to block the water not going inside. So the choice is yours, whether you want the lake to be recharged or you want to use the water, any water conservation structure, and the results and the activities will be surrounding to that. Thank you, sir.
Sir, one spot out. Can we recharge through borewell? If so,
can we recharge? I'm sorry, I didn't understand.
Can we recharge groundwater through borewell so that directly we can recharge the aquifer? If so, by aquifer mapping, why can't we implement on a larger scale? Next question is that since the Bangalore earlier it was a number of lakes were there. Now many of them are dried and many areas they have come up. Habitations are there. So in this, especially during the monsoon, being a low-lying area, areas will be urban flooding will be there. It definitely happens. In that case, how to recharge the groundwater? That is, any other highest codes are there within the habitation without affecting the foundation of the building.
Right. I mean, your both questions are very interesting. I can understand. First question I'll address is the borehole recharge. Actually, you mean, sir? Actually, if you are doing any recharge activity which is direct, you have to take care of two things very seriously. One is the quality of the water, which is you are putting it directly into the aquifer, because in one borehole you are taking, and in the, say 10 meters away, your neighbor may be taking out that water for a drinking purpose or some other purpose. So you need to be, one needs to be very assured of the quality of the water. In case you are putting directly from the rainwater, even then you should be assured that it is not polluted by any sulfuric acid, which is actually some fumes are there. Sometimes it actually, the rainwater is not the purest form water in an urban environment. It is a purest form of water in the book, in the rural environment. And we need to be very careful. Secondly, the recharge in a borewell needs, it's highly dependent on the recharge rate. Actually, in most of the Bangalore city or in the surrounding areas, the primary porosity is limited up to the top level. And in case the borehole is there, we block that top level and we go deeper into that. And in case you have the dry fractures or open fractures, which ultimately will take the water and recharge to the groundwater, it is dependent. I told you the recharge rate is maybe very poor. Generally, it is poor in the Bangalore areas. So you should have a small storages on the top of your area, where when the rainfall intensity is high, You can collect that water, filter it to some extent, assuring the quality. Please let into the borewell. So many successful experiments of the Bangalore itself have come, and we have conducted those experiments. I have myself done this experiment in IIT Delhi area, where the recharge rate was consistently at around 4 liters per second. I mean, we never thought at that time, even though the aquifer is completely full, even then it was taking the water. So it's a very good technique, but you should be very assured of the conditions there. Second question was your urban flooding. Actually, no doubt you have a very good seminar which is coming tomorrow also on urban flooding. Uh, uh, in urban flooding, you are aware of one thing, that some area you can, what you can do is, I can give you an example. We did some study for the Merit also, that you identify the pockets where the urban flooding is taking place, one, and then you go back, actually go back to the watershed which is leading the water into that particular area. Either because of the construction, you might have blocked the natural drainage. That is one of the main reasons why the urban draining comes. If you have actually allowed the natural drainage, the urban flooding will never occur. I am very pretty certain about this. We did, again, I'll tell you the studies in the IIT, in the JNU area near Vasant Kunj also, where we actually avoided, we constructed the recharge structure in the upstream of the watershed areas. You need not to work on the downstream areas. Don't allow the water to collect first. Urban flooding, you don't allow it. You work on the watershed, small areas, you recharge there itself. And then, or the latest Jal Shakti Ban, catch it where it falls, and the problem will be handled. But you need a concerted effort. You need to understand the topography. You need to understand the groundwater condition, groundwater flow also, and then take up recharge. You will be successful.
Sir, my question is very simple and straightforward. Integration of surface water and groundwater. Are you happy with the integration process with your rich experience in the Central Groundwater Board? The integration. Because I want to conclude by saying that I'm a student of water resource management. I want to refer to 1995 Integrated Mission on Sustainable Development by Department of Space, ISRO. Then the Sujala Watershed Project, 4th district to start with, then replicated to another 4 districts in Karnataka. What we find is an integration of groundwater sources and the surface water management. For example, Karnataka State Council for Science and Technology has literally mapped all the surface water bodies. When Vijay, he is now the secretary KSCST, for all the villages and panchayats. So very simple question. Groundwater potential on the one hand, we have got the telemetry. See, from groundwater, the borewell data is put into satellite imageries and it's getting into satellite network, Then the data is being, the inventarization is there. I find a small gap of the surface water bodies and the groundwater potential integration. So linked to the same part, for example, my knowledge says the Australians who are one step ahead in the groundwater recharge is what I have learned. And they go for even artificial recharge. They pump the water through the aquifers depending on some validation and all. Anyway, I want to conclude by saying that, as you rightly pointed out, since 14 years, with little care, I am recharging my borewell. Since 14 years, with the filtration. One of my colleague, Ganesh Raj, tomorrow he may come here to present, he taught us how to do it. The media, very clear-cut quality concern like preempting the first wash in the rains, cleaning the roof properly, things like that. And we are recharging the ground borewell for the past 14 years. And also taken the sample sometimes to see the levels and monitor it. The water is good. Thank you very much, sir. Thank you.
Thank you, sir. Firstly, I must compliment you for your efforts. I mean, the society, because if you don't, let's not lay all the issues with the government actually, or the policy framers. because who is the user of this resource? User is an individual who's in the house, farm, industry, or agriculture. So if all the users have to come together, your isolated effort is a pilot work, which can actually go very deeply into all those areas. But you can be a pioneer, but only you are doing it. Rest everyone is extracting it. The benefits are a little bit subdued actually. The problem is the technology is there. The need is there, the availability of water during the monsoon is there. You see the urban flooding. Generally, there are certain issues with the rainfall intensities. Bangalore doesn't have that much problem. Northern states have so many problems because you people means the southern part of the Bangalore have rainfall for spread over for 80 to 90 days in a year. We have just for 17. We means the northern parts we have around 17 days water out of 365 days. So that's a management problem, that so many floods come and the storages are definitely issue. That's how the surface and the groundwater interaction goes. Now your second thing was the Australia is the pioneer. Sir, probably we generally forget. We live in the present. We generally forget the past. India, we did one of the best studies in the artificial recharge in Gujarat and in Haryana, two places, and we did under pressure in 1970s actually. So we it's a very well documented also. Under pressure you can do, under hydrostatic pressure you can do. There are two types of under more than one atmospheric pressure. You can put the water inside, it will take, but you need to have an aquifer which can get or absorb that pressure also. We need to study. Unfortunately, you can see the people around you, or there are so many people around you, those sitting in the hall, outside in your locality also. There are not many people, those who have studied the groundwater as a science actually. They have studied this groundwater as an experience actually. No doubt the science and experience are correlated, but we need to have a systematic approach to a problem, not ad hoc measures. And I can tell you, it's a common resource pool, water, groundwater. I am fully for the integration of the surface water, because that water becomes ultimately groundwater and we need to utilize it whenever the rains are not there. Whenever we need it throughout the year, we need to have a very holistic and concerted planning so that the area which is having high demand in any month can be supplied whenever there is a shortage, or from the areas wherever the excess water supplies are there. I'm not advocating the transfer by trains or otherwise. Thank you, sir.
Thank you, Sanjay sir. I hope your session and answers were informative and clear to the audience. Next, I would like to invite Dr. Nayan Sharma, former professor, Indian Institute of Technology, Roorkee, to present a topic on rehabilitation of existing dams using piano key weir technology to augment flood storage and spillway capacity. This session would be online.
Well, good afternoon, everyone. Can you share my PowerPoint? Is it visible?
Sir. Yes, sir, you're visible, sir.
You are visible. Presentation is not visible.
Presentation is visible?
No. We
No,
are not
sir.
able to.
So your presentation is not visible yet.
Is it visible now?
No, sir.
Can you do it on my behalf?
Sir, I am sharing your presentation on your behalf, sir.
Please do it.
Now it's visible, sir. You can continue this.
Okay.
Yes, thank you.
Well, I'm going to speak on a topic which is very important in the current context of climate change. And in this regard, I had some exposure abroad when I went to Lausanne, EPFL. So there I was exposed to this piano cuvee technology a few years back. And for the first time in France, several old dams, they have transformed them to dams with storage as well as with more spillway capacity. Next, please. Next one. Can you go to the next slide? Hello?
Yes. Slide.
Ajay, can you go to the next slide?
Who has shared the slide, please?
There is a technical error. Please, can you spare for 2 minutes, sir? They are working on it.
Okay, I will wait. Yeah, it's coming now.
Yes.
I think you'll have to help me out. Okay. Well, the next, please. Well, I will only summarize. As you know, IPCC has worked out very extensively on how the climate change is going to unfold. And this is what they have given in the latest assessment report. The bottom line is there are going to be more floods and more droughts, and especially due to La Nina. Means La Nina is more creating rains, and El Nino anyway drought. Next, please. Next slide. Okay. Well, basically, as far as India is impacted by ENSO, that is El Nino Southern Oscillations, and there La Nina is creating rains. The next is IOD, Indian Ocean Dipole. And third one, I have not written here, that is Madden-Julian oscillations, which has this year create big havoc. So the bottom line is that we in India, we are going to have very severe occurrences of climate extremes, which will create a lot of floods as well as droughts. And for both floods and droughts, we need to do something for the dams. And just for your information, in India, we have about 6,000 dams, and majority of these dams are hydel dams. And even the earlier older dams, the storage capacity is not commensurate with the requirement, because now more extreme floods are going to occur, cloudburst events, and at the same time, more droughts will occur. Next, please. Well, in this context, the technology I'm going to speak is piano cuvee, and one more also, fuse devices. But as you know that, let's talk about Karnataka. There are so many dams. I think hydel dams, Almaty, then Krishna, RKRS dam, many other dams. These dams are predominantly maybe hydel, And even those which have been designed for flood storage, they are inadequate. So now the challenge for engineers is we have old dams, very old dams, 100 years old dam, 70 year, 80 year. So prima facie, it seems there is no way, no technological way to increase the storage or to increase the spillway. Well, this is what I could learn in Switzerland from Dr. Lamperier and the other Swiss experts. And they faced this problem in France. So in early part of this century, they come out with this solution of piano ware, and they retrofitted, that's the word used, retrofitted 70-year-old dam, 50 years, 60 year, by using this technique. I will be showing you some visuals, and they provided some storage capacity as well as spillway capacity. The credit must be given to Dr. Lamperier, a French engineer who did this, who is the original inventor. And I am really very fortunate that in IIT Roorkee, he gave us not only funding, but technical know-how as well. Next, please. Next, yeah. This I have already told, and I will skip this, that global warming is creating a big havoc, everybody knows. And globally, we are facing this problem of dam safety. So we need to go for retrofitting. Next. Well, the advantages of piano ware that it can be placed on an existing dam. It takes hardly 6 months or even less. In European countries, they do very fast, but we did some in India also, maybe, but still should not take more than 6 months to another 8 months. Advantages, it creates some storage, but I must highlight storage at MWL, maximum water level, and it increases spillway discharge as high as 5 times of a Ogi spillway. So that means it is capable to discharge even huge cloudburst flood. And third, as we know, a lot of sediment are there in the rivers, especially in northern Indian rivers more. But of late, wherever the watershed is getting denuded, sediments have started coming, even in Deccan Plateau also. So these piano ware can, unlike a vertical ware, it can allow, facilitate passage of sediment. Next, please. Next slide. Well, this is what you are looking at, a broad geometry of a piano ware. It has a rising ramp or rising inlet, and then it has a falling inlet. So we need to determine what should be the configuration of different members. Next, please. Well, I will quickly share very interesting results done in US. Now you compare a piano ware with a conventional spillway. Let's take 1000 cubic is the discharge. And in this particular visual, the head over crest is fixed 3 meter in both the cases. So with a 3 meter head for a conventional spillway, you need 90 meter spillway length. Whereas with same 3 meter head, you can pass 1000 cubic with only 20 meter. So it is hydraulically highly efficient. Next slide. Well, this is another case where you have 5000 cubic discharge, just for example. And in this case, the head over crest is not same in both the cases, but the spillway length is same. That's 60 meter in both the cases. So with 60-meter spillway length, to pass 5,000, you need approximately 10-meter head over crest. Whereas same 5,000 cubic with same waterway, spillway length 60, you need only 2 meter to pass. So in other words, that balance 10 minus 2, 8 meter at MWL level, maximum water level, can be kind of storage. Next, please. Next slide. So we can summarize that PKW, piano wear, can pass a flood discharge with much less wear length than an OGI or sharp crested wear. The capital cost is very less because it is ungated. And obviously hydraulic efficiency is more. The waterway gets magnified. It can be increased, the waterway can be increased as much as 5-6 times. And there is no O&M cost because it is ungated. You don't need any gates to lift. And obviously the spillway capacity is much, much more. It can pass 3 to 5 times more. And obviously the dam safety will be better. Take the example of Machu Dam failed in Gujarat in 1979. Some 10,000 people died. And that kind of havoc can be prevented because it is capable to handle much bigger flood. Mind it, with climate change becoming more and more sharper, the more extremes, hydrology of extremes are going to happen. And then the Indian dams, 6,000 dams, and especially in Karnataka as well, you have problem also in dam storage capacity. You have some problem with the neighboring states. So that can be resolved without much difficulty because you can store water, you can have more discharging capacity. As I said, a PhD student of mine, he worked in IIT Roorkee. We found that almost 80% incoming sediment is passed downstream. And a very important advantage is with that, it creates very less efflux because of hydraulic efficiency. And this study we have given advice recently to Maharashtra Water Resource Department. I'm going to show you. We have handled a 100-year-old, 105-year-old dam. So these are very clearing, very telling advantages. Next slide, please. Well, being engineers, we are very much keen to know the cost. In this regard, Dr. Blake Tullis in the United States, he conducted some analysis. So I'm only borrowing his, whatever he worked out. Next slide. Next slide. Yeah. In this slide, he worked out the cost. Dr. Blake Tullis from Utah State University in US, and he found the difference. Next slide. Okay, in this slide, he worked out the cost for a piano cure in American dollars, and in gated spillway, the cost differences are, as per his analysis, around 4 times. That means you'll be saving 4 times of funds if you go for piano cure. And if you, because the gates are not there, or recurring maintenance is not there, but I still recommend a small combination of gates and a big piano cure. I'll tell you later. Next slide, please. Well, as I said, I had the leading country is France. So the first piano cure technology was applied in a French dam, Goulers. That dam was around 70-year-old dam. Like in Asian countries, Europe has undergone very great deal of climatic changes. So they wanted to find an answer, and That is how piano QA technology was developed first time in France, in Paris, by Dr. Lamperier. And they have applied in 2006. Next slide. Well, designing in the initial time, in 20 years back, it was entirely dependent on physical model studies, scale models. So to develop this piano QA configurations for Guller's Dam, they conducted model studies in France. And as you know, the France has very good physical laboratory. And they, on the right side, you are seeing the lab. Next, please. Next slide. Well, this is that Guller's Dam, 70-year-old dam. And this dam, now it is more. In 2006, it was 70-year-old. So you can add another broadly 20 years. So it's close to 90 years. So this dam, the France engineers, that is hydraulic, France ETH, they blasted the right side with very controlled blasting. And they have, as you can see, they have installed these piano QA on the right side of the dam. Next slide. Well, this was another view of the piano QA, that Guller's piano QA dam. As I said, this is a very old dam, and they have installed on the right, along the right abutment. Next slide. Well, this is the view that all dam spillways are not required. The entire flood discharge, most of the discharge are passing through the right side piano QA. And this photograph probably is around 2008. And this is very close to, it's not far away from Paris. And it is working very fine. And with this success story, the France government, the French government have installed now 15 dams, mind it, 15 dams, all old dams, and these are all dams plus 50-year-old dam. They have installed. I am going to show you some of them here only. In the design, I was involved in during my stay in Switzerland, in Lausanne. I was involved in the model studies along with the Swiss professors. Next slide. Well, this is Latroy Dam. Here you can see this is again 75-year-old dam. And they have, unlike Guller's, which is placed on the right side abutment, that facility was not there. Probably the abutments were not strong enough. So they didn't want to risk even control blasting. So they decided to prefabricate the piano QA. And as you can see, they removed these gates and put in the middle at a very vantage location. And this was done in 2010. Next slide, please. Well, this is the Latroy Dam after it is completed. See, this is now almost 80-year-old dam and done. And if I'm not wrong, they completed this entire operations in 5 months only. And it's working very satisfactorily even now. Next slide. Well, there is another dam, St. Mark Dam. This dam again is around 70-year-old dam. And as per hydrological analysis, they found that the charging capacity is not adequate to pass the enhanced discharge, because this dam was designed pretty long back. The hydrological data pertain to much earlier. So they conducted fresh hydrological analysis, and they wanted to increase the spillway capacity as well as the storage capacity, both. And here too, they have prefabricated mostly, though it can be done there itself, but in this case also they prefabricated, and they did second stage concreting, which you are seeing in the dam itself. So in the next slide, you'll be seeing that St. Mark Dam is working fine. Next slide, please. Yeah, kindly have a good look. This again is a hydroelectric dam. It's about the height of the dam is about 55 meter. And this dam, they had a problem. Problem was on the place where on the right side where they had removed those gates, radial gates, and they installed a piano queue where there was some issue about part of the water coming down is not geologically robust. So they did some small change in the profile, as you can see, and it's working very good. Next slide, please. Well, friends, the Asians are not behind. I will say some engineers in Vietnam, they mainly Dr. Wind, he is a forerunner. He also conducted a lot of studies on piano ware. They did mostly physical scale model as well as CFD, computational fluid dynamics study. And this is not a case of old dam. This is a new structure. Sorry, okay. The new structure, and the discharge is quite high. It's something like 15,350 cubic. It's a big discharge, and this is a major tributary of Mekong River. Mekong is very large river, as big as Ganga River, or maybe comparable to Brahmaputra also. And they installed it in recent times, and it's working fine, as you will see in the next slides. Next, please. Next slide. Well, this is during the construction of piano QA. Well, very interesting feature of this Van Fong barrage. It's 18-meter high only. And here, the entire waterway is not piano QA. The piano QA is placed on both the sides, and the central part is gated. In fact, I am supporter, I'm a votary that we should have some gated spillways as well to exercise some control over the river. Next, please. So next slide, you will see it is working fine. All the piano QA, they're discharging very efficiently, and this is in Vietnam, and it can pass, as I said, something like close to 16,000 meter cube per second. Very high discharge. Next, please. Next slide, yeah. Well, friends, I had an opportunity when I came back from my visit from EPFL Lausanne, Switzerland. After returning here, I was very fortunate that one of our past students, he became an important functionary in Himachal Pradesh Power Corporation Limited. So they were trying to design Sarakudu hydroelectric project, 120 megawatt, but they faced a problem. This problem I am relating of 2008 and 10. So the problem was they applied for loan from ADB, Asian Development Bank, and as per their norms, 1 megawatt cost in 2008 should be around 7. So they cost 7 crore, 1 megawatt cost, to keep down the cost per kilowatt hour. But if they designed it as a conventional dam, the cost came something like 12 to 14 crore per megawatt. So this former student of IIT Roorkee, he requested me that can you come out with some solution where the civil works cost can be reduced. As you know, in a hydroelectric project, broadly 80 to 85% cost is civil, and around 20% maybe the electrical installations. So if there is any economy introduced in civil works, the cost of the project considerably reduces, and obviously it will have good impact on kilowatt hour cost. So in this regard, I'm very happy that I could do small contribution. Next slide, please. Well, we in 2009 and 10, we conducted some physical scale models. I'm standing here. This is IIT Roorkee. So we made a physical model, and you can see, I hope you can see the piano cuvee in the central part and gated spillways on left and right flank. And another big problem in this project was a lot of sediment was coming from the watershed, because as you know, Himalayan watersheds are quite friable. A lot of sediment comes, everybody knows it. So if more sediment comes to a hydroelectric project, then the turbines get quite often out of action. So that means the intake structure or the diversion structure or the dam should be capable to cut down the sediment going to the powerhouse. And that's what we could do here as well. Next slide, please. Well, this model was operated in Roorkee in the running, and here we used step spillways in the for energy dissipation, and in the central part we placed those piano cuvee. Almost 80% was piano cuvee and balance 10% on both sides. Probably the next slide you will see. The next slide, please. Yeah. So this is during construction. When it was put up in 2004, they started building, but now this is complete. Next slide. Well, this is the Saurakudu design model studies by us, by me and my team. And I'm very happy that for the first time in a big hydroelectric project, this has been very successfully operated. And only on 2021, 2 years back, our Honorable Prime Minister, he inaugurated on 26 December this piano cuvee, first time in a major hydroelectric project. So it's working fine as that. Next slide. Next slide. Well, this is, you can see, this is animation also is there. And the beauty is in a piano cuvee, the waterway is magnified. It can be more than a normal linear waterway. It can exceed from 4 to 7 times. So here we have used 6 times more. Next slide. Well, here you can see that in the central part is the piano cuvee. This is very recent photograph, and you are seeing the desilting chamber, and you can also see the power intake just hidden, and one undersluice is visible. So it is a combination of gated plus piano cuvee. As I said, almost 85% piano cuvee to minimize the cost, and just to exercise some control over the river, some undersluices are given gates. Next slide. Well, another technique, very quickly, probably I don't want to take too much time. Fuse plug is also used globally in many cases. It is like a collapsible dam. A fuse plug can be installed, and in very high discharge, it gets collapsed or it can go washed away. But it safeguards the dam and it creates storage as well. Next slide. Next slide. Well, probably I don't want to go too deep because probably otherwise too much time will be required. So fuse plug, these slides will be available with BIS. They can freely share with the the irrigation engineers from Karnataka, and they can always ask questions to me. So I don't want to dwell. Next slide. Well, this sketch broadly defines what is fuse plug or fuse device. On the upper side, you can see that the spillway capacity of an existing dam can be increased by chipping off a 1 or 2 meter of the top portion and installing the fuse plug. The lower one shows that it not only increases storage, not only increases the spilling capacity, the charging capacity, but it as well as increases the storage capacity. So in my view, we have to work both increasing the charging capacity, increasing storage. Like in Karnataka, there are so many dams where the storage is a big issue. And because if you can increase storage, you can store water for drought, mind it, for drought. Lot of interstate problems can be sorted out. Like Kaveri, there is a problem going. So one solution I suggest to Karnataka government that they can jointly with Karnataka and Tamil Nadu, they can solve this problem of storage. They can store more water, more for flood. They can store water for drought also. Very quickly is fuse devices, fuse plug, but definitely more lasting is to go for a piano cubate. Next slide, please. Well, in Australia and United States, they are doing, so this need not be a concrete structure.
Excuse me,
It
sir.
can be made of earth as well. So this is sketch. Probably next slide we'll see it is real.
Excuse me, sir.
Yeah. This is a Coppertown Dam. I will very quickly go. This is time is going away.
Sir, you
So
have 5 more
please
minutes,
go to the
so
next
please
slide.
conclude
Okay,
this.
this again I go. Please skip. So this is about fuse plug. This is the last part I am coming now. Well, I had a very good chance to work on an old dam in Maharashtra, Asola Mandha Dam. This dam is 105-year-old, and I was approached by Maharashtra Water Resource Department only last year before last. And we conducted physical model studies. We conducted mathematical modeling, both as well as CFD. CFD is an advanced version of mathematical modeling. And for the first time in India, we have used arc-shaped piano cubeware. I think nobody in India has done so far. And probably in the whole world, this may be third or fourth. The advantage is in arc-shaped piano cubeware, the discharging capacity is immensely increased. It can be as much as 5-6 times of an OGI. And it can store water. And this is an old dam, mind it, not a new dam. Very close to Nagpur. This dam was built in 1918. That's why 105. Next, please. I'll quickly show you the visuals. This is the dam located close to Nagpur. Next, please. Well, we conducted CFD analysis. So in CFD, there are many ways. I recommend one should go for LES, large eddy simulation, which is the best. There are so many models. People, they don't, without knowing the physics behind it, they jump and use average value. That's not the right way. And physical model also. Please, I want to wind up, finish. Next, please. So what achievement is that with a very small head, we could complete this. And Maharashtra Water Resource Department is now going to implement from 2023 to 2024, a 105-year-old dam, Asala Manda, is going to have a piano keyware. And it will, the beauty is, next slide, probably it is there. Yeah, please see. The beauty is the storage capacity right now is 7 million cubic meter, 67 million. From there, it will have 2 times, 120 million cubic meter, 2 times. And see that As a result, please read carefully. The irrigation potential is right now only 9,000, so 10,000 hectare. From there, it will jump 5.5 times. From 10,000 hectare, it will become 55,000 hectare. 5.5 times irrigation potential will jump. Storage capacity will become 2 times, and with a very small raising of 2.7 meter only. And it is done in a 105-year-old dam. I really feel so happy. The Maharashtra Water Resource experts came from Nasik Central Design Organization. They came 2-3 times. I will show you. Next, please. Probably those photographs are there. This is the CFD model. Next slide. This is the physical model we did. We want to validate. Next, please. This is the physical model, arc-shaped. Next. See, these are the design team came from Nasik Central Design Organization. They came twice, and they are fully convinced. And this is the first time in India a arc-shaped piano keywear is going to be done. This is the chief engineer and super engineer. Everybody was present. Next slide. Thank you so much. And I hope if there are any clarifications, any doubts, they're welcome to raise those.
Thank you, sir. Is there anyone from the audience who want to ask questions to the speaker?
Congratulations for this innovative initiative. My only question is, what will be the impact in the submergence area when the storage increases?
Excellent question. Very, very good. Well, I congratulate the speaker. I don't know him personally. Well, this was the basic problem Maharashtra Water Resources Department faced for Asalamandha Dam, 105-year-old dam close to Nagpur. Very rightly, this was the problem. If they go for a conventional Ogi spillway, even with a high coefficient of discharge, having a sloping upstream, even then the submergence was massive. And this is an old dam, and this is mainly a earth dam because it was built in 1918. As the respected speaker has asked, their main question was how to minimize this submergence. And we tried different kind of piano keywear. First, I tried the one I used in Himachal, that straight line one, not arc type. The submergence was still good, quite substantial. But once we have gone for arc-shaped piano keywear, the submergence came down drastically. So if had it not been an old dam, 105-year-old dam, if it is a new dam, I could have brought down the submergence by another 50%. But due to old structure issues, it was not done. But I assure the respected speaker, because he asked a very brilliant question. I'll say it is a brilliant question. And the submergence can be as low as 70 to 80 centimeter in case of Asalamandha Dam. And that is almost we achieved. I hats off to my that speaker as a questioner. Thank you so much.
Can I ask the question, sir?
Please do.
You mentioned that the storage capacity was doubled, that water basically is doubled, right? Available water is doubled. Then how come the users can get 5 times that benefit? Because it will be proportional to per user water. If we assume average consumption, then the users will be doubled, right? Or the area which is actually getting the irrigation.
Well, the watershed area, it depends on the upstream lake configuration. This is done by them only. I'm not involved in that, but I can still answer your question. My job was to design it. See, they worked out that if around 2.7 meter height can be increased, then the water spread area, because it is the entire lake was a diverging contour. This is what I was told. Diverging contour means with small increase, the area increases tremendously. The storage capacity is very large. Man, the storage elevation curve is very sensitive to higher. So they found that if whatever they increased, that means by increasing by the 2.7 meter, the storage capacity will jump from around 9,900 MCM to, 67 MCM to 120 MCM. This is as per their Central Design Organization, NASIC, they worked out. But they want to know how to cut down the efflux. This is what somebody asked. They want a minimum efflux, minimum submergence. Otherwise, the entire whole embankment will all be overtop. So that study was done by Central Design Organization in Nasik. But I can guess that probably we all water engineers, we know that if the storage capacity is a function of contours, if it is a gorge area, then even with 1 meter increase, there will not be very high increase in storage capacity. But it so happened in case of Asalamanda, the watershed was diverging upstream, diverging. So with small increase, there's a massive increase in the storage capacity. So it is.
Sir, that answers the question about the submergence. Sorry to interrupt, but that answers the question of submergence, which the previous question was about that how the submergence increase. That actually is the slope of your catchment, right? If the slope is gentle, then water will spread much farther. So that is one thing. Submergence and the irrigation area in the sense of the I am assuming that this actually is in the command area, not in the catchment area.
No. It is command area. It is not catchment area.
That's what. So irrigation, the users are all in the command area, not in the catchment area. So the submergence is one aspect. Regardless of whatever submergence happened, but ultimately you said that the increase in storage capacity was less than twice actually. But you are saying that more than 5 times the benefit in case of the command area usage. That I didn't get actually how that was possible.
Well, Mr. Nages, you're Mr. Nages?
Yes, sir.
Yeah. Let me be very honest. See, my job was not. This was done by Maharashtra Water Resource Department. They have got a chief engineer sitting in Nagpur. They worked out that with this more additional water available. Water availability is a function of the dam and its lake. It has nothing to do with command area. So that is again function of how much increase in efflux, and that efflux should not overtop the existing embankments, So my job was how to minimize the efflux. Same thing, if I use a Ogi spillway, the efflux will be 2.5 times more. I got that for table available. Means to achieve this, I need an Ogi spillway 2.5 times more head over crest, or I will say increase in efflux. So as my part, I have achieved. But how they got this exercise, I'm not the right person. It was done by Maharashtra, I will say chief engineer level in Nagpur, Mr. Devgare. His name is Ashish Devgare. I remember he's still there. So his team, Ashish Devgare and his team, they probably conducted a topographical survey of the command area, and they found that if this discharge is available, and depending on the crop, because again, it is a function of the crop. If you grow rice, you need a lot of water. If you grow millet, you less minimum water. So probably the command area increase, I'm guessing, is again depends on the crop water requirement. So probably that answer, the best person should have been the chief engineer sitting in Nagpur. But I achieved. He told me you cannot increase this flux. So I achieved that part. And
Yes,
I can answer that only.
Another thing is your original dam was earthen dam, right? So your piano structure was put on top of that. Actually, what was the what
No,
was the
no.
method?
Again, it's a good question. Original structure is an earthen dam with a concrete spillway. You know, everywhere, even in earthen rockfill dam or earthen dam, the spillway has to be concrete. But in this case, we visited this site, and unlike the French dam, you have seen Gullers, you have seen Saint Mark, that was not attempted because here there was a lot of saddle available. Saddle means some depression area and some outfall channels. So we selected a outfall escape channel area and we could place it. So the civil structures were very convenient. So if we didn't touch the existing spillway, existing earth and rockfill dam, earth dam, it was not touched. It was done on a straddle escape channel. If you are very keen, I can show you that photograph, or it is available. I think you can.
Yes, sir. If you could share the before and after pictures, that will become very clear, sir. I mean,
See,
just as
after
a
is not it. They are going to implement. They
I
have done the
think,
implement.
okay.
I think it's
They are
time
going.
for.
They have accepted. They
Okay,
have
thank
done
you.
very very comprehensive. They came to our labs
Excuse me, sir.
3 times,
Sorry
Sir,
to
we
interrupt.
can
and
have.
even CFD they try to understand. I really give hats off to Nasik Central Region. They not only investigated, they cross-checked our physical model. They did measurements themselves also, but CFD is very complex. Normal people don't understand. Being a professor of IIT, I know it very well, and I guided many PhDs on this also, more than 20. So CFD also they
Sorry,
understood
excuse me, sir.
and they cross-checked.
This is similar to dam stones. 500 years back in Bangalore, Kempegoda did dam stones he built. It is similar to that.
Very good. I'm not aware of that. It must have been. It must have.
Yes, yes.
Thank you, sir, for your.
Thank you.
Excuse me, sir. Myself, Ina Kausar, assistant
Okay, any questions still? It's a new technology. I want to propagate and people should know. And before I give her a chance, I am thankful to BIS that in 2010 I submitted, and now BIS is going for a Indian standard code on piano keyboard. So probably there is a meeting on 27th of this month, dams and spillways, and this will be probably taken up.
Okay,
Please ask.
one last question. You can ask
Yes.
and then we'll wind up. Please.
So what are the disadvantages of this piano keyboard? Disadvantages, and on what standards you have designed it?
You come to me, I will tell you.
Okay, very good. Number one, right now there is no standard at this point.
Yeah.
When we designed it, after I came from Switzerland, we discussed this. There was no Indian standard. Even now there is no Indian standard. So this was relied being from IIT Roorkee, and we have worked extensively. So probably the Indian standard is going to come, and the BIS officials are here. So this is going to be taken up on 27th. Now the advantage, you ask advantage or disadvantage?
Disadvantages. Advantages are more. I want to know the disadvantages.
One major disadvantage is if you go only for piano keyboard, only, then you don't exercise any control over a river. We must, I'm basically a river engineer, and in river we must exercise control over the river, so that when I want to release more water. When I don't want, I should do. Only entirely piano keyboard, the disadvantage, you lose control over the river. That's the reason both in the piano cuvette I designed and now in operation in Himachal, we put about 15% gauge and 85% piano cuvette so that we achieve cost economics, hydraulic efficiency, sediment passes, but we retain control over the river by that 15%. Same thing in Vietnam, same thing in Europe, same thing in in Maharashtra government also. So one major disadvantage that. So we must take care. Second is, unlike you can't pick up a book and design a piano cuvette. I have seen people trying to do that. It's very complex hydraulics, complex in the sense that it is specially very slow. So unfortunately, at this point of time, the designer not only should know physical modeling, scale modeling, but he should have some knowledge of numerical analysis. He should know, I will say, computational fluid dynamics. So that is not even known to many people. So it's not difficult, but one should learn exercise. So designing needs this. But otherwise, it's a very good technology. And I'm getting a lot of requests from other places also to help out in this particular. Even though there is no Indian standard, mind it. I hope I answered your question.
Thank you, sir. Thank you very much. Now, next speaker, please. Thank you very much.
Any other questions? Any?
Yes.
Or
Thank you,
my
Nayan
email
Sharma,
ID
sir,
is
for
there.
your
They can
informative
always send mail to
presentation.
me.
Your knowledge and expertise will really help all the engineers to learn and grow. Now, I would like to invite Dr. Ajay Kumar Naitani for a technical session.
So very good afternoon, one and all. The dignitaries sitting on the dais, and the engineers from the Karnataka state. Myself is from the National Institute of Rock Mechanics. We have a head office at Bangalore only, and one branch at Kolar Goldfield. So this today, can you make on the PPT mode, please? Full screen, can you make it? Full screen. Yeah. Maybe some problem. So what I'm telling that we have the geological investigation and subsurface investigation that is pertaining to the WRD 5, a committee of the WRD 5. Let it be like that only. Maybe some issue. So for last 15 years, we are, as a person, I'm contributing from the National Institute of Rock Mechanics. And this, with the importance of the site geological investigation, why it is required actually, and what will the impact if the proper investigation will not be done. You see the most important part is the geological and the structural feature of that particular area, the rock mass and the intact rock properties, and the most important, the institute stresses, the design, and the construction methodology. Will you see these first two parameters? They have the impact on the last three, that are the in situ stresses, the design, and the construction methodology. So means the design and the construction methodology will be decided based on the detailed investigations. And the what if the inadequate investigation will be done, then what will be the impact on your structure? And it's very simple that it will be the overrun time. And if overrun time will be there, then definitely it will have an impact on your cost also. And we have a number of the example across the country and in Karnataka also, that a proper investigations, if are not done, then all the projects are delaying. And this delay is because of the improper investigations. Next, please. Can you make next slide? So what is the ultimate goal actually of this investigation? To get a actual condition of the ground where we want to make it our civil structure. And from the planning to construction and the operation stages, whether these investigations will have a vital or the crucial role, the answer is yes. I can change this. Okay. So the most critical part in the civil engineering is the making the underground structure. If we compare with the surface structure in India, now we are making the underground structure for the storage of the crude oil, for the metros. Even in the Bangalore, we have an underground metro station. Tunneling is not a new concept now in India. If you see the 10-year backs or 15-year back, everybody was having fear. Instead of tunneling, make a cut on the slope. Now this is some sort of the concept that the tunneling in the planning phase, our bureaucrat and the planning team are accepting our concept. But the planning of the underground and the surface structures is totally different. Now, which type of the challenges actually, whenever we are talking, mainly all the nuclear structure, they are on the surface only. Foundation will be on the surface as per the design requirement. They will be 10 to 15 meter only below the surface. All the reactors. But if you compare the underground structure, whether it's a tunnel or the cavern is nothing but a big size cavern. It is for the strategic point of the view we are making, mainly in the coastal area, east coast or the west coast, or for our transportation or the metro purposes. But the challenges we are facing in all this underground excavation is uncertainty of the geology. In general, the engineers know this by the term the geological surprises. Of course, that word, it is not there. No question of the geological surprises, but it is introduced by the technocrat to satisfy the bureaucrat. Because the question will be there from the bureaucrat, from the government. Very general, this thing. When the new election will come, the government will try to commission that project. The project is delayed. Why the project is delayed? So a lot of geological surprises beyond our control. But fact is, no word is there in the geological dictionary regarding the geological surprises. What the things will create the problem is the hydrogeology. The hydrogeology and people, because one of our speaker told regarding the subsurface or the groundwater, but groundwater is more critical when we are making my structure below the ground. That is the more critical. And if you see, if you take the example of our peninsular India or southern India, what we are talking, or the Himalaya, except the Indo-Gangetic plain, we have a porosity and permeability is not there. All the permeability is the secondary permeability. If water is there, it will be in the form of the pockets only. We cannot have a water table at all because the terrain is not the sedimentary. Only in the sedimentary rock, we have a porosity and the permeability. If you think that Bangalore will get a water table, no question of getting the water table. And the third is the in situ stresses. In situ stresses means this is some sort of this thing. Then when we are excavating, when we are removing the material, then some readjustment of the forces will be there because we are removing the things. Making the underground structure at a shallow depth is also problematic, and making the structure deep is again the problematic. What is the requirement? The requirement is the medium stresses. But our requirement will be not satisfied when my planning is different. I want to make the metro, it cannot be as per my requirement, as per a geologist requirement. It will be as per the requirement of the site conditions. So sometime at the shallow depth means low stresses. In Himalaya, at deeper depth, high stresses. So this is the only region that the project will be delayed. At shallow depth also, it will low stresses, deeper depth also, the high stresses. So means these conditions can we know before this thing, before making a structure, the answer should be always, yes, we should know this. What is the condition of my geological condition, the hydrogeological condition, and the stresses conditions. So that as per concurrently with the excavation, when I'm making my tunnel, I'm excavating my structure, some problem will be there. So there should not be a delay in the management part, because the management should know that which type of the difficulties we are going to face during the making of the civil structure. So that should be again, how to make a strategy actually, how to collect the field data, and how to collect and how to go for the testing at the laboratory. Whether it is possible to test all the samples? No, it is not possible. Everything is dependent on the cost. If you go the laboratory testing, the data required for the design point of the view, the shear parameters, shear strength parameters. If today you see the population of my country and the projects going on across the country and the laboratory facility available in the country, we may have accredited by some agency, but whether that up to that mark we are having, no. Why it is not available? Because the cost of that machine itself, the person required to take the value, what the value is required, that is not there. That is not there. So how to go for that? How the question will come, how to optimization of this field investigation, optimization of the laboratory investigation, and again, the question will be there, the optimization of the in situ investigations. And somewhere because my design, our previous speaker, Sarma was telling he's a very good designer. He can take only one value. But what is the area of my structure? What is the area of my structure? And one value from the laboratory, one value from the geology, and one value from the in situ should be recommended. So who is going to recommend that one? Who is going to recommend that? So some sort of this thing, because this is a big planning is required whenever we are talking about the investigations. Now this thing, as I told you, that can we get the 100% information? No, not possible at all. Regarding in situ, extent of time is the another some sort of the maybe new term for you people. But the extent of time and the groundwater, all you see, when I am making my structure, underground structure, we'll start with the boring, drilling, then the blasting, then the defuming, then the mucking, then the installation of the support. This is my one cycle. What is the requirement? We should get in 24. Work will be 24 into 7. 24 into 7 per day, 2 cycles are required. If 2 cycles are required, whether it is possible actually. To go every cycle, I have to put the support. If you go this thing, my progress will be slow. It is not possible that whatever we are expecting, that the project has to be completed in 5 years or 7 years. It is not possible at all. So we should know that one, that extent of time. Extent of time means, suppose my mucking, suppose I'm removing material, how much we can remove? We can remove 2 meter, 3 meter, maximum permission can be given for the 5 meter. Every 5 meter, whether my rock is going to fall and it will sustain, if you go my next cycle and again I can remove my this next 5 meter. So that we call the extent of time. If it is not permitting, no question of this thing. But can it permit? Yes, it can be permitted. The same thing, if you see heavy ingress of the water, not reported. Or heavy loss, because you see, somebody, our speaker told, or maybe a speaker from the audience, that Hyderabad was having the 800 lakes, not Hyderabad only, across that state, number of the lakes. And my underground structure is passing below the lakes because of poor planning, poor investigation. We don't have time to go for the investigation, proper investigation. And during this thing, because that much of the cover was not there, it will be flooded. My crew, they are illiterate. Now we in India, we have a high-end side machines, but crew is very low. They don't have a proper trained crew to handle the situation actually. And then the problem will be more. It is coming? Okay. Are you doing something? Oh. So then next, I'll see from here. So this thing that what is the aim of our WRD5? If you go and maximum our subcommittees, some overlapping is also there. But you see, whatever the new things we are getting from our experience, and we are getting the feedback from the stakeholders also, because our colleagues from the BIS, they are there. You can be a member of the BIS. You can have a feedback in individual capacity also. You can be a member of the now BIS, and whatever you are learning, whatever the lacking is there, that can be incorporated, modifying new codes. All the committees, they are making. I will show that last year we have published a new code on the tunneling. Now, this thing, I think will move this, otherwise time will not be there. So I will come to this thing, actually, the stages of the investigations. Now we have the 4 stages of the investigation. Unfortunate part is we have a 2 contact system because all of you are the engineers. So I can discuss that with you people. One is the BOQ and EPC. Unfortunate part is in EPC, nobody is doing the feasibility or pre-feasibility stage investigations. Directly, we are jumping to the construction actually. Without making a proper geotechnical report, where you will make a geotechnical report? When you approach the World Bank or Asian Development Bank, because it is a mandatory for the not Indian banks. Asian Development Bank and the World Bank, it is a mandatory that you have to make a DPR, and they called it as now a GPR, not a DPR. So the stage, what the beauty of these stages, if you go with the pre-feasibility, then the feasibility, then the DPR, then the construction, at least you see in the pre-feasibility, what we are doing, whatever the literature of, because the planning is there, planning will be done by my planner and my politicians. The planning will be done. Whether it is feasible at the ground to make that structure, from where we'll start? We'll start with the pre-feasibility. Pre-feasibility means, if you people remember that across the country, we have a 1:50,000 scale map published by the Survey of India. And again, these maps are superimposed by the geology, by the Geological Survey of India. So you take those maps, now remote sensing data is available. The feasibility, when you say, okay, feasible, but we have a 4 or 5 sites where we can make this structure. Now 4 or 5 sites are there. You will next, what will be your recommendation? So 4 or 5 sites are there, and we have to go for the feasibility stage investigation, because the pre-feasibility means whatever the literature is there. In general, we'll recommend for geology, only refer Geological Survey of India data only, not from the universities or other institutions. And then next will be by the feasibility. When feasibility means some in the, now say 5 locations are identified. In 5 locations, some surface and subsurface investigations will be carried out. And the preliminary design will also be finalized. Preliminary, as Saab was telling, he has recommended first this shape, then this shape, different shape. So 5 sites, what are the merit and demerit of the 5 sites? And one site, only one site will be recommended for the DPR stage investigations. So when we are moving from pre-feasibility to feasibility to DPR, the scale of the investigation will increase, enlarge. Means at larger scale, we can go ahead, we can move this thing. Next, this is, as I told you, that how the difficulties we are facing. Okay, I am having, okay, good. The clarity is there, good. So just I'll show you this thing. These are what it is written in the red font. If you see, the potential sites, not sites, potential sites will be there. So whatever this literature will be there, in the feasibility stage, the feasibility stage means the preliminary design should be finalized. Preliminary design should be finalized in that case, and the recommendation will be at the one side, the detailed project report has to be done, all the investigation for the DPR stage investigation. Now, if you jump to the DPR stage, now this is some sort of this. Suppose if you take the example of this thing, the nuclear power plants. The nuclear power plant is having this condition, that the surrounding area of the 50 kilometer should not be seismically active. So what we call that study, the seismotectonic studies, means whether the lineament is nothing but the fracture, long fracture you can say, thrust you can say, fault you can say, these structures should not be active. So DPR, what will start the investigation, the large scale feature. So suppose some thrust. So in case of the Himalaya, two thrusts are very prominent, MCT and MBT. What is the strike length? More than 2,500 kilometers. Suppose these type of the features are there, at the smaller scale, you have to investigate at the DPR stage. But at smaller feature, as the length is less, then it has to be investigated at the larger scale. Now this is a geological mapping, you see, a proper. Now we have now we are collecting the data from the pre-feasibility stage, then the feasibility stage. Now we have started the mapping at ground. So ground means, again, if you refer our BIS, in the BIS, one code is there only for the scale of mapping. Please refer that one. Suppose you are making your canal, you are making your road, you are making your tunnel, everything is giving what should be the scale. If I'll go my nuclear power site, my scale of this thing is 1:60. If you go my hydro, I can increase from 1:100 to 1:200 only. Foundation of the dam. But you see, if you go with the tunnel, it cannot be done on 100 or 200. 1,000 scale itself is the sufficient. Then a detail this thing, you have to plan what you are making actually, whether it is a tunnel. Suppose my metro station is there. I cannot go with the 1:5,000. Maximum 200. Nuclear, 60. Fix. Nuclear is controlling by, because you all are the engineers. So nuclear is, the body is for the nuclear is AERB, Atomic Energy Regulatory Board. For hydroelectric, all these codes are basically for the hydroelectric. Water resource means hydroelectric, but we are using in all the fields. This hydroelectric will be controlled by the CEA and CWC. They are the controlling agency. And Geological Survey of India is the partner of the CEA and CWC. All the geotechnical report and geology report will be reviewed. They have one office, their head office at Calcutta, but they have one office at the Delhi. They will review all the report part. But other than this, hydro and nuclear, we don't have a regulatory agency. We don't have any regulatory agency. You make your, as I told you, the contract is awarded on the EPC basis. That is up to the contractor, whether they will do an investigation, and without investigation also they can start the construction, because regulatory body is not there. Only at the two areas, atomic energy, systematic. Hydro you cannot move. You have to get a clearance from the CWC and CA. But other agency, for each state, we have a central design department, but they will not stop the work. They will not stop the work. Whatever this contractor they want, they are following, they are going as per this thing. So what will be the next in the DPR? This is geomorphological study. Sometimes people are ignoring that subject, geomorphology. It is a very important, and the site selection, mainly the alignment of the tunnel, because the length of the tunnel will be more than sometime 1 kilometer. So this study, this geomorphology, and this is this sort of these all, I'm showing our example where we have done the work for the hydro power. So this type, you see some sort of the 3D map we can generate. And this is finally, this is the beauty of the DPR. If you see in this map, we have all the geological unit. This is the plan map. And the component of the structure, means the dam axis, it is shown. Then the spillway location, then the diversion tunnel, all the tunnel portion, powerhouse area. This all the component has to be laid down before making a section. if your plan is perfect, means your section will also be perfect. And your design will be based on your section, but the section will be based on your plan. So plan of the, during the DPR at the scale, and this, as I told you, this is the structural discontinuities. If you see in broader this thing, at the 4 scale, you can differentiate these things. They are the regional, as I told you, their length is more, and then the local and the minor and the discrete. And all these things are important. In general, if you people have learned maybe regarding this grouting, that the grouting has to be done before putting the foundation of any foundation. The grouting means the improvement of the subsurface strata. Whether the grout will take or not take, that is always a question. So this minor, if you have a minor information regarding this discrete fractures pattern, then you can decide. In all the hydropower projects, all the nuclear power projects, grouting is must. Only the difference is in my civil structure, my Luguen value, permissible Luguen value is 3. But in case of the nuclear, my permissible Luguen value is 1. It is very difficult to take the grout actually. Then what has to be done? If you see which type of the cement we are using, because this grout will be as per your fracture space. And your fracture space, suppose it is less than the size of your cement, whether it will take? No. Then we have to go for the ultra fine cement or the super fine cement. So you see, if you have a data that in the beginning, DPR, suppose you are not having data and the grouting has to be done, and you have not mentioned that super fine cement will be required, you have simply mentioning that grouting will be required, then the cost will increase like anything, because grouting is must. Without grouting, the designer will not allow you to permit you to pour the first layer of the concrete on the foundation. So these type of the structure are very important, and we have to see. Now the next is the geophysical investigation, very important. You just give me 5 minutes before you inform me, okay? Then I will stop there itself, okay? So one part is the geological. I'm trying to explain you the sequence, because you people are the design making also, that when which type of the investigation has to be done. First is the survey. First you start with the survey. Next is the geology, surface geology. So far I am discussing regarding the surface geology only. Next, if it is required, go for the geophysical survey. Geophysical survey in general, what is written here, why it is required, but presence of the geological pitfalls, presence of hidden defects, and rock mass characterization. So this is the indirect method and non-destructive method, geophysical methods, for the identification of the rock type. Now this is how it is working actually. It is based on the signals only, and this is how you can make a choice actually. In general, in one part is the geophysics, general geophysics, another is the engineering geophysics. For you people, engineering geophysics is only work, not a general geo. What the NGRI Hyderabad is doing, they are doing all type of the geophysics. But what our organization is doing, we are doing only the engineering geophysics. Means we are restricting up to the certain depth, will not cross 300 or 400 meters. Because my structure will be up to that depth only, will not go beyond that one. So engineering geophysics and general geophysics, there is a difference. Sir.
5 minutes.
Okay, sir. So this is this thing that we have in general, three type of the methods we can use. Seismic, again, the refraction method. This is being used by across the world. Whatever I am discussing with you, this is across the world, this is being done. Then the resistivity, mainly resistivity means mainly for the water body, or identification of the water body. And again, GPR, I think you people are aware about this, the GPR. This is the how we can, the seismic survey, where it can be used, the electrical resistivity and GPR survey. This is just I'll show you the example of this thing. You see, you will get this type of the, suppose your tunnel is there, go for the this resistivity survey. This type of the beautiful section you will get. So we have a four color means four type of the material, and you can finalize your alignment. Suppose you don't want to lay down that one below that particular label, then you should be aware of which type of the problem you are going to have during the construction. This is the resistivity. You see, the dark blue color are the body with this water bodies. And this is the special type of the test generally for the River Valley project we are conducting. This is the cross-hole tomography. So between this, on the either side of the river, we'll make a hole, and both the side of the hole will make this thing. And now we'll superimpose the geophysical map on the geological section. And geological section actually, again, the drilling. Now, first part is survey, second part is the surface geology, third part is the geophysics, fourth is the drilling. And finally, it will be the drifting. But drifting will be done only in the drift is nothing. The drill hole you people know. This is why this is survey cost is less than geological survey cost, then the geophysical cost. And this borehole, if you remember this thing, it will be in our southern India also, the cost will be more than 3,500 rupees per meter. So it has to be planned again for all this thing, for all geophysics, whatever I have discussed, we have a BIS code. Kindly refer all those code. For the beautifully we have made, this BIS have made the code for the drilling, how it has to be done. Two codes are there. One for the logging for geologists and one for maintenance of how the core has to be maintained. And this is we are, as I told you, whatever the new technology across the world, it will come, we'll try to incorporate in our this thing. The one is the optical televiewer. Some sort of you will get an exact photograph. This is the acoustic borehole televiewer. This is a high resolution acoustic televiewer. And this is, you see how we can make at the geological section. Suppose something is lacking. This is the drifting. Actually, drift, as I told you, is small tunnel. So drift is required actually for so many things. Because suppose we are making a dam. So how much that hill has to be cut actually? So different term, if you read on the red font, I have marked the weathering limit, distressing limit. So we are finalizing this thing that much of the portion from the foundation and that much of the portion from the abutment has to be removed. So how much from the abutment? It has to be decided based on only the drift information, and all the institute tests will be conducted because institute is required for design point of the view, and mainly deformation and shear. Shear means the CN5. What is shear? CN5. This is my strength. What is my deformation? Means how much load it will take. In dam, both are required. You see, that is the weight. And this is a shear. We have a water body. This is my shear. This is my weight. So where it has to be conducted. Because suppose we have a distressing limit, we cannot conduct the test. Otherwise, what happened in the Sikkim? Now the report will come. It is possible. Dam is for what? For the flood management, dam is one of the measures. And during the flooding, dam is washed out. Then, who is responsible? CM is telling quality of material. Quality is not. Design has failed. It is not a question of quality. Design has failed. So this thing, now this is the recent equipment across the country, we are using this TVM. And these are the some that I think that presentation can be shared. So the physical properties and what is the role of the engineering geologist. And it is all these things are mentioned in this thing. So I will not take much time now. And this is the model how we are doing. This is the construction now. The construction, as I told you, that how we are developing this thing. Now, scanner is also there. All the scanning can be done, the modern technology. And this is the rock mass classification. This is as-built map. Instrumentation again. This is not in our WRD5, sir. But instrumentation, always we are giving the emphasis that the minimum instrumentations are required. For southern our peninsular India, only extensiometer and this target reflector we are recommending. For Himalaya, we'll go with the high this instrumentation. For our peninsular India, that much of the instrumentation is not required. So these are the some problem already discussed. This is the first crude oil project in India, sir. This is at the Visakhapatnam for the storage of the crude oil, where we have developed our expertise in India actually, that when this project has come, that the technology was not available in India. Then we have developed Then 2 we have made in the western part of our Karnataka, Padur and Mangalore. The maximum capacity of the underground crude oil project is at the Padur only. So this is a concluding remarks, means whatever I told you, that how this the main 3 parameter, in situ stresses, stand-up time and groundwater. Yes, it is possible that during the investigation, if you follow our BIS, written very clearly written, if you follow our BIS, then we should not have any surprise. And this, what I told you, that this code is published on the tunneling. This code is published in the 2002 last year. And all this stakeholder, we have interacted with so many stakeholders. It took, of course, 3 years time to complete this thing, but finally it is completed. And thank you so much for your kind attention.
Sir, good evening. I am Surya Narayana from Central Power Research Institute. It was really a very, it is online, sir, online.
Okay, okay. Tell me, sir. Yes. Please,
sorry,
sir.
yeah. Very, very insightful and informative presentation, sir. Excellent presentation. I should congratulate on you for that. Sir, I have some 2 questions, basic. One is, sir, you said that for this EPC contracts, generally they don't do this geotechnical investigation. So regarding that, but sir, main thing is based on the geotechnical investigation report only they can design, sir. That is one part, because anyway, design is also a component of their responsibility. No? It comes under their responsibility. So that was my first question. Second is there are several advancements, as you said, and one which I understand is this multi-channel analysis of surface waves, which they use for this seismic surface and wave testing. Is there a standard for that, sir? Just these 2 basic questions I want to ask.
Your sir, this thing, your first question regarding EPC, what I'm telling that for design, some values are required. No doubt about it. But what I'm telling, because designer will take one value, whether it is a representative value, my answer is no. Systematic, because we are in BIS, we are silent. Suppose question is, so about 10 kilometer length of the tunnel is there. How many borehole? Depth, we can say that it has to go beyond the invert level of the tunnel. But what will be the spacing? So still in this last year published, we are silent on that one, because we cannot make a rule. Why we cannot make a rule? Because everywhere the site conditions are different. And when we are starting our investigations from pre-feasibility to feasibility, then the DPR, means a person is there, a person should be there in the team who can take a decision, maybe sometime at the 100-meter interval. Right now, we are making an investigation. We propose that below railway line, instead of making a flyover, go for the tunneling. At low cover, we are planning to make a tunnel in Indore area of the national highway. My the borehole spacing is 150 meter. We have decided that less than 150 meter is not sufficient to give a value to the designer, that this is my value. And EPC, if see the quality, what I'm telling, that whatever the investigations are required, again, whatever is being done in the Himalaya, that cannot be copied for the southern India. Himalaya is different, southern India is different. And I told my experience, because still we are dealing with the project, we are not having report. Report is not there. So any this thing lacking is there, because some agent for hydroelectric project, for the nuclear power project, AERB is there, CWC is there, CA is there, GSI is there. For other this thing, agencies are not there. Say in case of the highway, they are totally dependent on the consultant engineer. Consultant engineers means a third party engineer. Third party engineers means a private party. Private party. And they are not having the experience of the tunneling also. Because bill has to be routed, the contractor bill has to be routed through that consultant. So the third party consultant, third party engineer is there. but they are not expert. They are not expert. So it is lacking, sir. This is my, because day and night we are working and we are facing the problem like anything.
Very true, sir. Very true.
And this is the weak point of the EPC contract. EPC, I don't know, because last week only I was discussing at Delhi with the member highway. That at least what I'm telling, I tell you, sir, example, I will not take much time. When I told that we have developed our expertise for the Visakhapatnam project, and the government of India requested us to be a part of PMC for Padur and Mangalore crude oil project. Request is another this thing. They told submit your CV, your experience. EIL was the PMC, then we are a part of the EIL. Along with the EIL, all the responsibility NRM has taken for the Padur and Mangalore, including instrumentation, all these things. So that is not there. Then they approved our CV and they told these people can be deployed at site. All are having minimum 10 years of experience for the underground. So some sort of, what is our this thing, because always discussing with chairman of our WRD5, Nawani Saab, always in all the forum, we are discussing, sir, can we have some sort of this thing? At least I'm in the favor of this thing, that the people should have experience of this, that whatever they are doing, because EPC, that is the main reason. Even in the nuclear power side, the contractors are leaving, big contractors, they are leaving. And the next is coming. So this is this thing, sir. And next, your question regarding this thing, I think that code is not available, sir, so far. So including our organization, many other organizations are working, and maybe that now new policy has come from the BIS. We can take S&T projects also. Yes, sir? Yes, we can take S&T projects also for making a new BIS. And for many this thing, we are working with the NDMA, National Disaster Management Authority also, pertaining to their fields. Because in Karnataka, we are looking for Chikmagalur area, sir. Already we have submitted our this thing that Chikmagalur first will take up regarding landslide mitigation measures. So that I think, sir, because for landslide mitigation, whatever you are discussing that instruments, that code is not available. But expertise are there, and shortly I think we'll have a new code on that one, sir.
Thank you so much, sir.
Thank you, sir.
Any other question, if any?
Any question, please? Brainstorming is finished with 2 questions.
Thank you, Nathani Saab.
Thank you so much.
He stressed the importance of geological and geophysical investigations and engineering geology for design of structures, for operation and maintenance of structures, and how we can design our structures better, and later on surprises can be less and cost can be also within the limits if we go for adequate investigations in the beginning itself. So thanks again for highlighting these important points. Thank you.
Thank you, sir. Thank you, Ajay Kumarji. And I think Sandeep also has done some work on this. And I think aquifer mapping you are doing also. No, so that's because it is only for construction and strength point of view. What is the underground structures you are discussing?
Our purpose is suppose what is there, then
Yeah,
how
rock mechanics.
use that one.
Yes, that, but resistivity and all that hydrology, even we are using for that groundwater prospectus mapping for finding the groundwater percent, ma'am. And sir, thank you, very good presentations. And I request our BS director Bhanu Prakash to give the memento to Ajay Kumar as well as Sandeep. So now it is my privilege to thanks to all the speakers of today and all the participants who are and who are very seriously listening. And we had a very good afternoon session as well as morning sessions also. And I'm also thankful to our Dr. Shashi Shankar sir and our what is that? Sandeep Batra sir for running the show today. And I'm also thankful to our Bhanu Prakash, BIS director, who is the main architect of this program and tomorrow's program. And also I'm thanking to the people who have been the backbone of the event and the doing the technical arrangement, all the members and the participants from online, offline, all the members. I'm thanking you, and we will continue the sessions tomorrow at 10 a.m. on urban flooding. Thank you. Thank you very much.
Also thank Dr. Inayatullah sir.
And please have, we are having a tea. We will have a tea, and after tea, we can reassemble tomorrow morning at as sharply at 10 a.m. Thank you. Thank you. One night all. We will have a one group photo, all of us, all the participants and the members. We will have one group photo, please. Please gather at the dais, all the members who are here. Let us join for a group photo. Please come, sir, all of you, all the participants here. All the members. It's coming tomorrow. Huh? So
I think online participants also you can have one photo.